Happy Monday, everybody. Jeff Williams here from Auburn. Hope everyone's doing well and had a great weekend. And really happy to see the numbers we've got today. We're pushing over 100 right now. So thanks everyone for tuning in. And yeah, I'm watching the chat. So feel free to place where you're from in the chat box on the right-hand side. Nice to see some familiar names there as well. Hey, Maria. All right, so we're going to get going. Yeah, thanks again for joining us. And normally our COLOSS conference is quite condensed into a couple days, but we've been spending time with COLOSS now for the past over 2 weeks, and everything from my perspective has gone really well. We've had some great feedback, so hope all of you have enjoyed those workshops. Really great participation there as well. I think the average was probably 40 to 50 people for those workshops. So thanks again for tuning in. And I want to give a shout out to our beekeepers and other non-COLOSS friends over on Facebook Live. It seems like we've got about 60 people over there watching right now. So we'll say hello to you, and Allison from Alabama Extension will also be looking for any comments coming from your side on the Facebook chat. So I also want to thank Jack Rowe, Alabama Extension. Also, he's the one sharing screen right now, and he's the one that's going to be sweating behind the scenes, getting all our presentations and recordings ready to go. So thanks, Jack, as well. So again, welcome to our conference, and I'm going to throw the floor over to Peter here. So Peter, will you please unmute and say a few words?
Sure, I do. Thanks, Jeff. Yeah, good morning, good day, good evening, depending on your time zone. Also, welcome from my behalf for our first e-conference. We have the 16th conference in total, and in these difficult times, this is the only way to keep in touch and to do networking, what COLOSS is actually all about. So yeah, I'm really happy that we found a way to overcome this and to meet at least virtually. So thanks already in advance to the Auburn team to get these things organized, and thanks all of you participating here. Looking forward to this online meeting. Next, please. COLOSS has now, we have 12 years, and over those years, on the left, you see a map from 2008 when it all started. On the right, you see a recent map. I'm really thrilled that, we moved from 60 members, 27 countries now to 1,515 from 102 countries. It's quite amazing. So despite, all these worries in the past about our finances and, some, whatever issues, smaller issues, and we are doing extremely well, and we keep growing, and we keep tackling, timely questions for bee health globally at a global scale. So I'm really happy about this, and I think we're doing a good job. And next, please. And this is also reflected here. I'm absolutely truly delighted to announce that the Ricola Foundation Nature and Culture has decided to give us substantial additional funding. So this grant, is substantial again, and it will enable us to promote our networking and output in the next years and possibly beyond. So I'm very positive that if we're doing a good job, the Ricola Foundation will extend this funding beyond this current agreed period. Next, please. So the aims of this meeting are fairly clear, as with every COLOSS conference, providing an overview on global bee health. And we have from all task forces and core projects of COLOSS, we have state-of-the-art presentations. Then we're also hearing updates from the recent workshops, which apparently all went very well. And also we are for planning of our future activities and beyond. And this is, a apparent limitation of a Zoom meeting. We don't have, the physical closeness and these discussions and coffee breaks and so on, what is basically right at the core of COLOSS. This is not feasible via Zoom, so it will be only a taste or a touch of it, what our conferences usually are. But on the other hand, I'm also we're seeing many new names over here, people who were not able to make any physical meeting because of the apparent costs and logistics. So I think this virtual meeting has also a couple of advantages by bringing people in who otherwise would not be able to join. So I'm looking forward to this meeting, and I'm handing over to Jeff for the schedule. Next, please.
All right, everyone. Thanks, Peter, for that introduction. So yeah, here we go for our schedule. And actually, from now on, most of you can sit back and relax, apart from our some of our EC members and task force and core project leaders. So just so you have a sort of a highlight that we're going to have a series of breaks for the next couple hours. Between those breaks, more importantly, will be some state-of-the-art presentations from our core projects and task forces. So just so you know the format, each video from each core project or task force will last about 10 minutes. After that 10 minutes, we're going to have about a 5-minute break to ask specific questions for that video that you just observed. So while those videos are being played, for example, monitoring is coming up next, please, if you have any questions, type them into the chat at the bottom. And so, yeah, after every video, we'll have a few minutes time to pose 1 or 2 questions for our core project or task force leaders. So again, 10-minute video from monitoring coming up, and then we'll have 5 minutes to ask some questions of Robert and Allison. All right, next slide, Jack. Just to make sure that everyone can communicate properly, we essentially have 2 levels of participants right now. We have our panelists, which are people like myself, as well as the EC and leaders of those core projects and task forces, so they can unmute. Every other person is considered an attendee, and so the only way you can communicate is via that chat box. So if you haven't already, I would suggest to open up that chat bubble and click that, and usually you'll see a panel to the right. There's several different options of where you can place that, but the easiest is to the right. When you're writing your chats, make sure that you're selecting the appropriate drop-down menu. So when it says, it may say to everyone, on my screen, I can select if I want to send it to all panelists and all attendees, I can choose all panelists. So you want to send it to everyone or to all panelists and attendees. So that makes sure that it goes to the entire group. So if you just send it to, let's say the panelists, only a few select people can actually see those chats. So again, just make sure that you're emailing to everyone. All right, so that's pretty much the housekeeping. We're going to have some videos coming up, and again, they're going to be broken down or separated by some Q&As. So I'm going to allow Jack to get that video all set up, and yeah, everyone enjoy. Feel free to add some nice questions, and we'll pose them to our leaders here. So take care.
Hi, I'm Marcel Barthélemy, General Manager of Vito Pharma. Vito Pharma is a French pharmaceutical company with a strong expertise on Varroa treatments. We are the producers of Apivar and Varroa EasyCheck and the distributors of Oxybee in Europe. We have been proud sponsors of COLOSS since 2016, and we are happy to support your network in its different missions and see it growing year after year. It's crucial for us to support the research on the honeybee health industry, and we look forward to support more and more your projects. Indeed, our goal is to deliver innovative solutions to beekeepers, and to do that, we can support you with our unique capabilities on research and development and regulatory. Indeed, around 8% of our revenue is invested on research and development. We have more than 10 people involved full-time in research and development, from the formulation to the industrial transfer to manufacture new products. With the support of our 2 laboratories, R&D lab, where we can do development of new formulations, stability studies, and analytical processes, but also our B lab, where with our proprietary method, we are able to screen new active ingredients against the Varroa. In the last few years, we could screen more than 40 active ingredients and identify some promising families to propose new solutions to the beekeeping industry in the future. With all of that, we also have our own apiary with 250 colonies where we can try new formulations of authorized active ingredients and test new promising feed products. So please be welcome to take contact with us if you believe that together we can bring innovative and high potential projects to the beekeepers around the world. Thank you for your attention. I wish you a nice conference.
Hello and welcome to the presentation of the COLOSS core project on monitoring of honeybee colony losses. My name is Robert Brotschneider, and together with Alison Gray from Glasgow Strathclyde University in Scotland, I coordinate this project and prepared this presentation. There is about 80 researchers involved in what we are presenting here, and on the top of this slide you can see some pictures from workshops that we organized over the last years, mostly in February, where we physically meet and discuss the progress of this working group. So we're collecting data on honeybee colony losses. What has been there before COLOSS? Well, actually, there was very few data on colony losses, and there was no internationally standardized questionnaire or analysis or database of such colony losses. Already in the very first days of COLOSS, when it was funded by the European Union as a cost action, monitoring of colony losses was one working group in those days coordinated by Romee van der Zee from the Netherlands. Today, already mentioned, it is one of the 3 core projects of COLOSS and coordinated by myself and Alison Gray. And what we are basically doing is we're asking beekeepers in a citizen science approach, or to be more specific, in a crowdsourcing approach. So we do make open surveys. That means every beekeeper can participate in our survey, and we promote these surveys through different channels, and internet has become really important today, but also we write articles in beekeeping magazines, we attend beekeepers meetings, we have mailing lists, etc. I already said how important the internet has become. So about 20 countries currently use our common electronic survey, which is based on the open source software Lime Survey and kindly hosted by the Danish Beekeepers Association in the moment. In our standardized questionnaire, we ask essential questions from which we can calculate a honeybee colony loss rate. But we also ask optional questions which focus mostly on hive management. For example, if this is a migratory or a stationary beekeeping operation, what methods are taken to control varroa, what other hive management is done, but also on the environment, like for example, which plants did the bees have access to. We ask beekeepers how many colonies did they have before winter. Then we have winter, which is in most of the participating countries a few months long period where the bees don't have access to any external forage, where they reduce brood rearing, and we ask the beekeepers about the outcome after this period. And well, the colonies could be okay or could be weak, but we of course focus on colony mortality, and here we have 3 different categories. One, I'll start with the middle one, is natural disasters. This is when colonies die because of a fire, flooding, theft, vandalism, or whatever. So, and this is not a biological reason, so we don't include this in further risk analysis. But very important for us is if a colony is dead, for example, if there is many dead bees lying on the ground of this colony, or if the hive is empty, if all the bees are gone, and the colony could also be alive. So there could be living bees in the colony, but not a properly laying queen. So this could be a queen not laying at all, or a drone laying colony. And at this time of the season, it's quite difficult to put there a new queen into this colony. That's why we regard this also as a lost colony. Actually, we do further differentiate this first symptom that I mentioned here about dead colonies or empty hives, but I'm not going to speak about this today. Which countries do participate? And you can see here a list. In blue, the European countries, and in red, the non-European countries. And I must say that Algeria, Israel, and Mexico regularly contribute from outside Europe. But since 2 years, we also have Iran contributing. And new in this year, From Europe, we have Romania participating, and Egypt and New Zealand from the non-European countries. We do reach a different amount of beekeepers in each country, and I show you here the response rate of the 2018 and 19 study given as the percentage of beekeepers in a country. And what you can see here is that in the Netherlands, in Denmark, Scotland, Norway, Sweden, and Ireland, we have response rates of above 10% of the beekeepers in this country. So we have a really good picture and coverage in these countries. Other countries, we have lower response rates, and in some countries we are working, of course, to increase the response rate, but we only reach 1 or 2% of all the beekeepers. Altogether, we can see here that the number of responses, and you need to read the label on the left axis, is increasing, and you can see here the gray bars correspond to the number of responses, and you can see that in 2020 we have more than 30,000 beekeepers participating in our survey, and the black line here shows us the number of colonies, which we can read on the right side of this graph, and we can see that the 30,000 beekeepers that participated in the 2020 study collectively managed more than 1 million honeybee colonies. All the monitoring group articles are published open access, and they're all published in the Journal of Apicultural Research, and that history started in 2012 when Romain van der Zee and co-workers published a 2-year analysis of an international data set on colony losses. We contributed also to the COLOSS Bee book with our 2013 methodological article, and from 2016 on we decided to go for short publications presenting loss rate outcomes to the scientific community and focus on one effect that we are modeling in the respective article. For example, in the 2016 article, we shown that operation size has an effect on colony losses. Large operations usually do have lower losses than small operations. We also studied the effect of migratory beekeeping in another article. In the 2019 article, we could demonstrate the effect of different forage sources on honeybee colony mortality. And in our most recent article, we could show that the more young queens are in the colonies of a given beekeeping operation, the lower the losses are. Next to this, we also disseminate our knowledge and our findings to beekeeping magazines. For example, you can see here article from Austrian, Swiss, or Italian beekeeping article magazine. And these are the maps that we produce for these articles, and these maps allow an international comparison of the loss rates. Very simple here. Green means significantly lower risk for colony losses than the overall data set. Red means increased risk of honeybee colony losses in that particular year and in that country. And you can see here that in some countries we have a rather good coverage, so we cover all of the areas of these countries. But if you look here, for example, in Italy, Spain, Algeria, or also France, our survey currently covers only parts of these countries. And again, this is of course what we want to improve. You also see that there are differences in colony losses among countries, and you can also see, and this is for 2017 and 18, and on the right side we have it for 2018 and 19, that there is differences from one year to the other year. So the conclusions of this core project presentation is the level of loss vary across the years, the level of loss varies spatially, loss rates are lower for larger operation sizes, loss rates can be decreased when more young queens are introduced to the colonies. The effect of forage sources depends much on the country, and the effect of migration greatly varies between countries and years. Our goals are to increase the coverage of beekeepers within the countries and, of course, increase the international coverage so new countries are welcome to join in. and we are currently working on continuation to examine the risk factors for colony loss. Thank you very much.
All right, I'm going to call Robert and Allison to unmute yourselves. Thanks for that great video. So we do have a couple questions. Quite a few of them relate to, I guess, barriers for people joining. And just to show that we're listening to everyone on Facebook, one very direct question came, why are there no questions or surveys rather from the US or the UK in that one example?
First of all, hello. Can you hear me?
Yep, you're loud and clear.
Also, Alison is online. Maybe you also say hello, Alison.
Yes, hello. Hope you can hear.
Yes, we can nicely hear you. Well, lots of questions. I will reflect first to what Jeffrey Williams has asked, because I could not read that in the chat. This must stem from the Facebook stream. Why United States is not involved? Well, that's a different system. They are having their own very powerful organization that is collecting data on honeybee colony losses, which is, of course, the Bee Informed Partnership. England or United Kingdom was also mentioned. And well, Alison Gray is from Scotland, part of the United Kingdom. And actually, we do have data from Northern Ireland, from Wales, from England,
Scotland.
And from Scotland, of course. Maybe Alison wants to say something on UK.
Yes, we have participation from the whole of the UK. Historically, England has not joined in so much with this. And in fact, there are various different surveys going on in England. But 2 or 3 years ago, as of 2 or 3 years ago, we have a national coordinator in England. And he's based at the University of Leicester, and De Montfort, which is in Leicester, Anthony Williams. So England is very much present now, and we have quite good coverage of the UK, I would say. We also have Ireland, which is not in the UK but is nearby, so we're doing quite well there.
All right, so just another related question. I guess, can you discuss some barriers to a new country joining, and let's say a new continent getting involved? Like, is there any, what kind of approach can we take or you take to introduce new countries, and more specifically, new continents of countries?
Well, if I may start with answering this one, we are very active, I would say. So first of all, it took us a while to get almost all European countries on board, and you can still see that we have some white spaces on the European map. And we also are quite well doing, in my opinion, to get some North African countries on board. And what's the barrier? Well, the barrier is we are seeking for really engaged national coordinators in those countries. The barrier is very low. Send an email to me and Alison, and we will be in contact with you. And we tried in several countries with several national coordinators in the past, which did not work out in the end, that we have received really reliable and substantial amount of data. So the barrier is really to find good national coordinators. And for example, because I think Peter Neumann asked that question, well, during this conference, we were already in contact with another participant that was new to us from a Northern African country. We also included now, and we are in contact already 2 years or so with the colleagues from New Zealand. So we are covering the other side of the globe, if you want. So we are covering the Southern Hemisphere. And actually, my biggest hopes, or I think the biggest chances for extension, would be the Asian countries, because we have a very good system running that could be very easily translated to the situation in many Asian countries, and that's I think what we need to work on next. I saw in the chat that we have a participant from Japan, for example. We tried to hit Japan several times, but at the moment we have no reliable national coordinator there.
Okay. I mean, overall, I think you have to say you all have been very successful at recruiting countries, and I mean, just looking at those maps, they really look great every year. So, one quick question relating to integrating data from any kind of like smart hives or beekeeping apps. Do you like what does the future hold for the COLOSS survey? You know, can it start taking up more like, let's say, live data or something to that nature and integrating that?
That's a very important point, and we are discussing this very intensively also in our workshops that we just heard. For example, we were lucky to have one workshop in Toledo in Spain this February before the lockdown happened. And we need to say that it's very, very difficult because we need to speak also about data protection issues and intellectual property issues. So, and in my opinion or in my experience, very often such data from let's say applications or from electronic hive monitoring systems are collected either by private companies or by let's say European Union funded projects, and those projects have a duration of very few years only, and this I'm sure that this is high quality data, but I'm not sure if we have the XML standard, to name another phrase, to integrate these very different approaches at the moment into one high quality data file.
Okay, I see you might be somehow referring to Noah's question there too, in terms of creating any kind of like repository for data that others can then access in the future.
Definitely, that's one of the biggest things. And actually, in the last, I would say, 1.5 years, the real hard discussions were not so much on the science of what we're doing anymore, but rather on data protection, data sharing, data storing, handing over data to some other parties. And just to clarify this, it's really a complicated situation because beekeepers, private persons, are handing over us sensitive data, and they're handing it over to national coordinators, which are from beekeeping associations, or in my case, from university, because I'm a university researcher. And then we hand it over to COLOSS to make something out of it for the greater good. But we also need to protect, first of all, the individual beekeeper, then the national coordinators, and also we need to protect our intellectual properties.
All right. So thanks, Alison and Robert, for that. And yeah, if you have any more questions, feel free to contact both of them. So again, really appreciate those questions, and time to move on to the bee book. So Jack, take it away.
Hello, I'm Norman Carrick, and I'm speaking on behalf of the COLOSS Bee Book editorial group. So I want to start by talking about the origins and development of the COLOSS Bee Book project. And really it started in 2010 with a COLOSS workshop on molecular tools in honeybee research, which was held in Bern, Switzerland. And those present at the workshop concluded that there was a real problem with a lack of standard research methods which hinders efforts to look for the causes of honeybee colony losses. So in other words, the fact that there were many different labs around the world doing similar work, but using completely different techniques, meant that it was extremely difficult to compare the results of one study with that of another. And a really good example of this is work recording honeybee colony losses, which was using a range of different techniques, which meant that the data produced by one study really couldn't be compared with another. So there was therefore a need for standardization. And the idea emerged that this should be a manual of standard techniques, and it was decided that this would be called the Bee Book. And it's worth mentioning that in other fields of entomology, such as the study of the fruit fly Drosophila, for many years there has been a standard manual with all the techniques you need to know to work on Drosophila, so that for many, many years all the labs around the world that use Drosophila have been using standardized techniques, meaning that all of the results of their work published in many different countries, can all be directly compared. So what is the bee book? It consists of practical research guidelines for direct use by scientists, but also by extension specialists and by beekeepers. And the first 3 volumes contain some 2,000 protocols described step by step. So here, for example, is the technique of using icing sugar to detect varroa mites on honeybees. And this is a good example because it's something that's used in research labs by scientists, but it's also used by extension specialists, and it's also used by practical beekeepers. So the books themselves have been written by more than 350 authors in 35 countries around the world, a truly global project. So volume 1 is entitled Standard Methods for Apis mellifera Research, and it consists of all the basic research methods to work on honeybees. So studying behavior, chemical ecology, molecular biology, physiology and biochemistry, toxicology, cell culture, colony strength, endosymbionts, in vitro larval rearing, maintaining adults in cages, and then finally there's a chapter on miscellaneous techniques for honeybees. Volume 2 is Standard Methods for Apis mellifera Pest and Pathogen Research, and it has introductory chapters on epidemiology and on estimating colony losses, and then it has chapters on each of the important groups of pests and diseases. So the tracheal mite, the small hive beetle, chalk brood, the wax moths, European foul brood, nosema, American foul brood, tropilelaps mites, varroa mites, and viruses. And a chapter on the Asian hornet is currently being put together. Volume 3 is Standard Methods for Apis mellifera hive products, so different products of the beehive, and these are honey, pollen, propolis, royal jelly, venom, wax, and brood as food. So where can you find the COLOSS bee book? Well, firstly, online. So it was initially published in special issues of the Journal of Apicultural Research, and the idea is that one chapter of the bee book is one refereed article in the journal. And volumes 1 and 2 were published in 2 parts in early and late 2013. And then volume 3 has been published from 2016 onwards. The first chapters came out in 2016. Several were published this year, and the final chapter will be published early next year. As well as the online versions, though, from the outset, it was intended that there would be hard copies of the bee book for use at the laboratory bench. We concluded that every lab around the world should have a copy. So we published originally 200 hard copies, and those sold out quite quickly, much to our delight. And then when it came to reprint them, we decided not to use the same technique, but we decided that they would be made available print on demand. So now if you log into Amazon, wherever you are in the world, you can buy a hard copy of the COLOSS bee books, volume 1 and 2. And the advantage of it being print on demand is that if you are in Australia or the United States or Germany and you order a copy, it will be printed locally and sent to you, and this avoids the very heavy shipping charges that were a problem with the initial hard copies that we purchased. So volume 3 will be available in hard copy as soon as the final paper has been published. So has it been a success? Well, let's look at some statistics. In terms of downloads, more than 80,000 downloads have taken place, and this is data showing the number of downloads from the Taylor and Francis website since April 2015, which is when the Journal of Apicultural Research was placed on the Taylor and Francis website. And you can see that there are great differences in the number of times these papers have been downloaded, and interestingly, the most recently published have been the most heavily downloaded. And Propolis here is the third most downloaded JAR article, and Brewed as Human Food is the fourth most downloaded JAR article out of all the hundreds that are on the Taylor and Francis website. So that's encouraging. In terms of being used by scientists and cited in other papers, we can also claim success in total since 2013, when these were first started to be published. There are some 1,500 citations. And again, looking at the individual papers, Varroa tops the list at nearly 160 citations, and this makes it the fourth most highly cited JAR article out of the hundreds and hundreds of papers that have been published in the 60 plus years of the journal, which must be a success by any measure. But we haven't finished there, and volume 4 is under construction. And volume 4 will be looking at the eastern hive bee, Apis cerana. Now, many things about Apis cerana are similar to the western honeybee, Apis mellifera, but there are considerable differences, both in the way you deal with it and its biology. And so this new volume will consist of chapter 1, which will be a practical beekeeping guide, because there are many differences to the ways that you actually keep Apis cerana compared to Apis mellifera. Then chapter 2 will be general methods as applicable for Apis cerana, and this will be complement to volume 1. Chapter 3 will be pests and pathogens of Apis cerana, and this will be analogous to volume 2. And finally, hive products, which will be analogous to volume 3. So to conclude, we believe that with 38 chapters and growing, and over 20,000 protocols, the Bee Book has really become a useful reference tool for honeybee researchers, from novice to expert and other stakeholders globally. So we need to thank the 350 plus authors, the many, many reviewers who refereed those papers, and to our publisher and to our sponsors. So initially, COST, part of the EU that funded the original COLOSS project, paid for open access of the first 3 volumes. And then we must thank our current sponsors, the Ricola Foundation and Nature and Culture, and the Veto Pharma and IBRA, our publishers. So thank you very much for your attention.
All right, so Norman and Vincent, you there? Vince,
I'm
please
here, yep.
unmute. All right, nice to see you both. So we've got a couple questions. One is, I mean, we're often talking nowadays about like existing and novel threats to honeybees. What about like existing and novel things for the Bee Book? I know you both are aiming for like Apis cerana to expand it to new territory, but what about specific topics to update from the original Bee Book? Any ideas there?
Yeah, so I'm going to bring people up to date in the short 5-minute talk tomorrow. But essentially, yes, we always realised that from the start that there would be new threats to bees that weren't envisaged at the start. And so a really good example of that is the Asian hornet, Vespa velutina, which, you know, really wasn't considered a threat anywhere at the time the earliest chapters were put together as a plan. So that is hopefully being written at the moment by the crew from the COLOSS Vespa group. And we're always keeping our eye out for other areas. In terms of new techniques as well as new threats, we always thought that the molecular biology chapter would go out of date very rapidly. And indeed, you know, that may be the case, but I think also there are whole new areas of molecular biology that have appeared since that chapter first came out. And so Jay Evans, who I think is here somewhere online, is hoping to put together an additional work on omics, so genomics, proteomics, metabolomics, and so on.
Okay, great. And just connected with that, I mean, you're talking about, like, I guess some technologies regarding like molecular biology. Actually, Vince and I had an email that was coming from one of my USDA colleagues about like other types of technology, like hive tracking systems or, you know, hive scales, this kind of stuff. Any thoughts on like how the bee book can integrate like technology that's surely advanced in the past almost 10 years since the bee book first came out?
Yeah, I mean, I see there's also a question from Rafael Dell'Olio, which I sort of didn't cover in my talk, and that's really how we intended the bee book to be updated, and we always envisaged that, you know, laboratory techniques are improving all the time, and that people would have new ideas. So when we first published the chapters, as well as being refereed papers in the Journal of Apicultural Research, the COLOSS webmaster very carefully put the entire paper online on the COLOSS website in an HTML form with all the text and the illustrations. And for each protocol or each section of protocols, there was a section where anyone could add their comments, their ideas, their thoughts. And, you know, this was the original wiki approach that we thought would really work. Now, for reasons which we really don't understand, people were very reluctant to use that. And in the however many years that service was available, there were only 2 or 3 comments. I don't really know why. Raphael was wondering whether now COLOSS has a larger membership that could be reintroduced and people would come forward with more comments and suggestions. And that's possible. It certainly was a lot of effort for our then webmaster to do. And unfortunately, when we changed the COLOSS website, that section, that possibility disappears. But nonetheless, at any time, anyone can write to the senior authors of each chapter whose email addresses are on there and make suggestions. And then we always, you know, assume that when there is sufficient demand for an update, that the chapter will get updated. And that could be by the original lead author in the original author team, or if they don't want to do it, then other people could come forward, because it's worth noting that this has been around long enough to have a bit of history, and some of the key people who were involved in the early stages sadly are no longer with us or have retired, but many new researchers have come forward in those fields with new and exciting ideas. So, you know, if anyone looks at a chapter of the bee book and thinks, gosh, this needs updating, then please do contact either us or the original lead author of that chapter, and we'll see what we can do. The virus chapter.
Thanks, Norman. Thanks, Norman. We're running short. So real quick to Vince. Yeah, the microbiome. Someone posed a question: is there going to be any chapters on microbiome or opportunistic pathogens? Any comment there, Vince?
Yes, for the first volumes, we actually discussed this, and I'm not sure we integrated that time. And I think we discussed it again for volume 4, but as we just said, we're open for basically any topic. So if it's not already there, we will definitely consider including it.
Okay, great. So contact the editors. Another final question coming from Facebook. Is there any like alignment with the bee book and GLP guidelines or OECD or EPA guidelines with the bee book? And any thoughts on that?
Yeah, we definitely pay attention to what standards are already out there, and we try as much as possible to include them. But quite often, basically the methods the researchers need go beyond those that are already standardized for some issues. So we will usually repeat the methods are they described by other standardization initiatives and complete with our own that the experts of the field actually judge necessary.
Okay, great. And I'm sure Piotr and Noah have some great insight into that with the B book versus OECD. So, all right. Well, thanks so much, Norman and Vince. And I'm going to throw it back over to Jack, and we're going to hear about BRAP.
So, very welcome to the BRAP introduction, Bridging Research and Practice, and the importance of communication, or it takes two to tango. So we all want to have healthy honeybees, and the beekeepers, of course, and we have the advisors working with beekeeping issues and the scientists. But we don't speak the same language necessary. It's hard to reach out with information and it's hard to communicate. So new research or innovation results, they get lost. And the goal of BRAP is to ensure that new results of science reaches the beekeepers. So we have a kind of source, could be a researcher, it could be an organization, it could be anyone actually who want to reach out with a message. So the source is encoding the results and send out the message through different kind of channels. And then the message is received by the receiver, could be the beekeeper then in this case, who needs to decode the information. And then we have the feedback back into the source again to get this communication going. And we can also show it like this. We have the scientific knowledge system or the network of sciences working with different aspects of honeybee health. And then we have the beekeepers having their local knowledge, and their aim for knowledge could be accessed through different channels. And one important one is actually the advisory services, because they work in the middle between the science and the practical beekeeping. And the advisors within beekeeping, they have to decode the relevance of the information from the science systems, and they have to make it like, is it trustworthy? Is it credibility in this information? And how is it accessible? The adaptability and the complexity of the system from the science and the whole of beekeeping structure. How could this be packed in such a way that it's reachable for the beekeepers? And of course, how would science know what the actual problems of beekeeping is if we don't have a communication the other way around? So it's this two-way communication is very, very important. So the goals of BRAP is actually to improve the means we have to reach beekeepers, whether with the results from science, but also to get the feedback from the beekeepers back to science. So we aim to increase the knowledge of the COLOSS members on how to improve the dissemination practices. So, and I am Lotta Fabricius Christiansen, and I'm chair together with Linda Moravec of this BRAP core project. And I belong to the Swedish University of Agricultural Science, and there I work at the Competence Center for Advisory Services. I'm also a project manager and lecturer in beekeeping and pollination, and I'm also a beekeeper. So Linda, to you.
Hello, everybody. So as Lotta introduced me, I'm Linda Moravec. I'm working at the Austrian Agency for Health and Food Safety at the Department of Apiculture and Bee Protection. So I'm concerned with projects in bee health, but also with lectures and talks for beekeepers or beekeepers. From my training, I'm a zoologist. So BRAP had a certain number of workshops beginning with 2015. At the beginning, we had two chairs, Fleming and Preben, who started BRAP, who started the work going, the ideas going, and Lotta and me, we are very happy to have the opportunity to follow up with their work and to continue with all the ideas. So when we see what happens in the last 6 to 7 years, when you go, yes. So BWeb started in 2014 and 15, as I said before, started by Fleming and Preben. At the beginning, there was a very intense brainstorming phase. Lots of ideas were coming in, and these ideas in the end led to to free service about problems in communication. So the idea was, where are the problems? Define the problems that we can tackle them. So in the next years, these free services were developed. And last year, when Lotte and me took over, we began with this first survey, which was concerned with researchers and advisors. At the moment, we have a very exciting phase with the second survey, which is reaching the beekeepers. And in the next year, we also want to start the third survey, which is more concerned in beekeeping structures. But what are these surveys really about? The idea of the first survey is that we want to know how COLOSS members disseminate. Are they interested in dissemination? Do they think they're good trained in dissemination? And what do they do to bring the information to the beekeeper? The second survey, which is at the moment going on, is to ask the beekeepers, how do they get the information? Whom do they trust? What efforts do they do to get trust for full information? And how do they behave? And which tools do they use? In the third survey, which will start, as I said, next year, we want to know the different structures of beekeeping training and education in the different COLOSS countries. In our workshops, we are not only concerned with the surveys, we also want to give some input. So last year, we asked the COLOSS members in our Montreal workshop, what are your main interests? Where do you want to get some input? You see this little graph on the right, where there's lots of social media skills wanted. So to learn how to communicate both ways, how to communicate with beekeepers, also about general principles, for example, from social science and so on. So in the last 2 years, we started with giving some input to the COLOSS members. For example, in Gothenburg, there was a very, very interesting talk by Frank Wanclay about social principles of communication with agricultural people. And we also began to present some practical tools in Montreal, interactive online tools. We would have loved to bring some input about social media at this conference, but unfortunately the format didn't make it very easy to do so, and we hope to continue such projects in the future. And in the end, please, if you want to be updated about BWeb and our projects, please update your profile in COLOSS and give BWeb as your interest. And yes, if you are more interested in our contact detail, in our work, here are our contact details. And yes, Lotte, you want to say something in the end as well?
Yes, so since we are quite a new core project, we would like to have, of course, more people joining us. And it would be great if you have the possibility to work maybe a little bit more to disseminate about this topic within COLOSS and help us out to find interesting topics that we can bring forward to all the members later on. But otherwise, we would also like you to take part in this service and help us distributing them. So please contact us for further information about this. And we will mention it in the update report tomorrow as well. So thank you very much for listening.
Thank you. Bye.
Bye.
All right, Linden, Lotta, are you there? Okay, I see you.
Yes, we are here.
Nice to see you both. Okay, I've got a question coming in for you. So at least in the US, we talk a lot about short and medium term outcomes in like the extension kind of field. And so short term is related to like passing on knowledge, and then the medium term is like kind of creating this behavioral change once like a beekeeper gains knowledge. So what do you think right now is our main challenge? Like, are we still having issues passing on knowledge, or are we having issues making, let's say, behavioral changes, or maybe there's no issue at all and everything is great? Yeah, where do you think we should focus?
I think we know a lot through research and so on. We know quite a lot what we actually need to do to have healthy bees. And so I would say the information is not probably the most important problem to solve, but what we need to solve is actually how to reach out and make a change in behavioral. So the main challenge is there, but of course we have to see this like different parts in a bigger, if we look in a bigger picture, to be able to change and to have the right, if you call it right information out there.
Okay, and so from like both your experiences, and I know Lotta, you're a beekeeper for some years. Linda, actually, I don't know about you, but how has how's communication changed for beekeepers over the past several years, let's say, and where is it moving towards? Like more social media, maybe, or?
Yeah, if I can start answering, and then you can continue, Linda, maybe. So. I mean, now it's not easy to have, it's easy to find information on whatever topic, and you can find what you are searching for, but you don't know if it's a credible or it's a trustworthy information. So you have to have quite a lot of knowledge yourself to be able to distinguish between what's good and what's not. And since you have all these things floating around, accessible, so it's demands much more of the beekeeper, and I would say demands much more of the advisors or the ones within the beekeeping system, that to know that we have to face these different kind of views. If you say you can have a view on something, but research, should show what's actually the real situation. So how can we make this information more accessible?
Okay, and regarding that, like research is showing in some respects, like what we should focus on. Do you two have an opinion on what one or two things we should really focus on from a honeybee health area? That's coming from one of our attendees there.
Yeah.
Will you, Linda, do you start?
So I have no idea. I have to say, but I also don't think that's the thing. BRAP should focus on what, because we should focus on which tools we can use to speak with the beekeepers, and maybe to add something to the last answer of Lotta. I think we shouldn't be that sure from ourselves as scientists and advisors which are the correct tools, and that's to reach the beekeepers. Everybody speaks about social media, but do we know that beekeepers really like to be informed with social media? So I think that's the main point of the survey we are doing at the moment, to really ask them, how do you want to be informed? And then the decision what to inform them with, it's also a very central question, but I don't think it's the central question of BRAP.
Okay, and that question actually partially came from Robert Broadschneider. So there's a great example of how BRAP can join forces with monitoring or Varroa or the other groups to try to reach out and communicate with the beekeepers. So I think that was a good answer. Okay, so last question coming in is talking about your surveys and like, yeah, what practically can be gained from them, like looking to the future. Like you ask about like the structures of beekeeper education. So once you learn that, like what's next?
Yeah, if I start maybe just to, if we have more knowledge about how the beekeeping situation is actually constructed or how it's built in different countries, in different parts of the world, we could have a go on try to find solutions on how to reach out in a better way and to understand the different stakeholders involved in the beekeeping issues. So it could give us a better understanding of the differences between us, but also maybe the things that are similar that we can actually try to solve together, and what's not maybe.
Okay, so I'll just follow up with one question because I think it's quite interesting about like visualizing and communicating for beekeepers. So one of our panelists, or sorry, attendees asked, have we had any? Do we have any knowledge about like which kind of, let's say, figures, I guess, like visualizations effectively convey knowledge to beekeepers, and does it differ by the country or like continent, for example? Like ways to visualize things for beekeepers. Do we know anything about that?
We are not that exact in our surveys, so I think that would be also more question a social scientist should tackle. So that's very specialized, but it would be very interesting if there's different language in science, yes, in pictures.
All right, I think we'll have to end it there. So we're going to head into a break here. So thanks, Linda and Lotta, for that. Really appreciate that. Let me toggle through my screen here. So we're running a couple minutes late, but not too bad. So I'm going to have Jack advance us to a break, and if we can rejoin in 10 minutes. So you can stay on the line, yeah, run off and get a beverage or whatever you need to do. We're going to have a break, and maybe we'll have a third. Actually, sorry, Jack, if you don't mind playing that video of our sponsor here.
National Bee Research Association, IBRA, is delighted to be a sponsor of the 16th COLOSS e-Conference 2020. IBRA is a charity that promotes the value of bees by providing information on bee science and beekeeping worldwide. We publish Bee World and Journal of Apicultural Research. Visit ibra.org.uk to find out more.
All right, so thanks for that, Jack, and thanks to IBRA. They've been very good partners with us, especially concerning the bee book. So we're going to go into a break now, and I just ask everyone to be back here in 10 minutes. So we're going to start at a quarter past or 15 past the hour. So see you in a few minutes. All right, everyone. Hope you had a nice few minutes refreshing break. I just want to highlight that we've had some nice videos from two great partners, Vita Pharma as well as Ibra, in that first segment. Two of our partners didn't submit recordings. One of them is Eva Crane Trust, and as you know, you've seen their logo on probably our proceedings on for the maybe 6-7 years. And again, they've been really great over there, Sarah, for supporting us and of course supporting a lot of bee research and extension opportunities around the world. So they often issue requests for proposals. So keep your eye on their website when planning some of your extension and research efforts. They're really, again, really great organization. And then, of course, the RICLA Foundation has been with us basically from the start. And yeah, their foundation and their directors have always been tremendously supportive of our efforts. So thanks both to them. Okay, so for our next segment, we're going to roll into hearing state-of-the-art presentations from some of our task forces, starting with Varroa. So Jack, take it away.
Dear friends and colleagues, we are happy to present you Varroa Control Task Force, our recent work and future plans. As you all know, Varroa mite is one of the main challenges of today's beekeeping almost worldwide, due to its direct damages and those caused by the viruses it vectors. At the moment, we have around 80 members from 24 countries registered in the task force. We base our objectives on the philosophy of integrated pest management, a combination of tactics that mainly act to strengthen a honeybee, emphasizing tactics specifically targeting the mite, keeping use of synthetic acaricides at minimum, and thus reducing resistance development, as you see in the graph presented. General objective of Task Force is to develop sustainable solution for management of the Varroa mite that is composed on a combination of activities and based on the results of Varroa monitoring. To be more specific, our aims are to evaluate beekeepers' practices against Varroa on efficacy and safety for honeybee population and products, to improve current management options and to develop novel strategies, to evaluate diagnostic methods for Varroa infestation levels, to assess the impact of the different infestation levels on colony survival and productivity, to explore mechanisms of Varroa tolerance and resistance in different honeybee population in collaboration with Bee Breeding and Survivor Task Force, and finally to provide recommendation to beekeepers for sustainable Varroa management in collaboration with BeeRep Core Project. Because of some shared aims, workshops of Varroa Task Force, Bee Breeding, Survivors and BeeRep commonly go back to back. What is our general work stream and how we deal with the Varroa problem in our task force? First, we discuss it in the groups. Then we formulate the research question. Then the interested colleague or leader construct an experimental protocol, volunteers are identified among the members, and the experiment is executed. Working under this scheme, until now, we had several common experiments conducted. The first we present here is evaluation of on-field methods to assess Varroa mite infestation on honeybees, in which 6 researchers on 10 apiaries, including 177 colonies, performed 3 protocols. The main goal was to identify the best method to suggest for beekeepers to assess the phoretic or even total Varroa mite infestation of honeybee colonies. Also, to verify if icing sugar or soapy solution wash methods are suitable to verify the efficacy of treatments at the apiary level. The second one is management of Varroa with formic acid. The aim of this research was to improve our understanding of the impact of temperature and humidity on the efficacy of formic acid treatments. The research was performed in 4 countries and included 16 apiaries and 260 colonies. 5 formic acid dispensers were used. Per apiary, 2 or more dispenser types were tested in 2 to 8 colonies. There are some difficulties in interpretation of results, and new analyses need to be accomplished before the conclusion can be published. The results of this recent activity are now published in Journal of Apicultural Research under the title Summer Brood Interruption as Integrated Management Strategy for Effective Varroa Control in Europe. It's the result of 2-season research in 10 European countries on 370 colonies, in which we tested the efficacy for Varroa control of different brood interruption methods, like queen caging, brood removal, and different trapping techniques. Briefly, we report high efficacy of treatment consisting of queen caging followed by 4.2 oxalic acid treatment. Further, efficacy of pure biotechnical methods without usage of any chemical treatments did not differ significantly from the queen caging group. Besides efficacy of different treatments, we tested influence of methods on colony strength and average workload needed to perform all activities. Several workshops were organized before the start of the experiment to ensure that used methods are applied equally on all research sites. For more details, please look for the article. At the moment, we have 3 ongoing activities: CSI Varroa, or Citizen Scientist Initiative for Varroa Economic Damage Thresholds, then Impact of Brood Interruption on Colony Productivity, which is extension of the brood interruption research, and preparation of Varroa book which is intended for beekeepers and extension. The aim of CSI Varroa activity is to define the economic damage thresholds. Are they different in different ranges, and how they are influenced by the treatment practices? Currently, there are 6 countries involved, and national coordinators have translated the protocol in their native language. A data collection sheet has been created and uploaded on the Google Documents. Key parameters to follow are infestation levels and colony strength. Data collection will continue until early spring of 2023, while Lyme survey tool will also be ready till the end of this year. Data available from other projects may also be used. The outputs of the activity will be recommendations and a scientific publication. Different brood interruption methods can effectively reduce the infestation of colonies with mites in summer treatments before rearing so-called winter bees. However, there is not much knowledge of the impact of brood interruption and queen caging on honey production. So, the aim of this activity is to investigate the effect of different brood interruption techniques on the colony honey productivity. Experience of members until now have shown kind of opposite results, and with this research we aim to have reliable information on this topic. In 2019, research was performed in 4 countries, where different timing of queen caging was compared with the control group for honey production. We are planning to repeat the research with more partners and also to include trapping comb techniques. We see it as our obligation to disseminate the outcomes of our research. For this purpose, we initiated compiling a Varroa book. A book that is first of all beekeepers oriented, but can serve also anyone interested in management of the Varroa mite. The book will address the main methods and challenges of Varroa management, considering climatic conditions, as well as local operation practices and different operational sizes. It will provide tools for skillful selection of optimal practices according to climatic conditions, operation size, and availability of legislated products. Its 12 chapters are in preparation. During our last workshop in Puavi, per suggestion of members, we are planning 3 new topics: evaluation of the significance of drone population to Varroa infestation, which is basically the research of drone population dynamics in colonies and its effect on Varroa population development; then effect of colony distribution and density on reinfestation of colonies with Varroa mite, with aim to gain more knowledge in this field, and in vitro Varroa rearing with aim to continue experiments on Varroa in months when it is not possible to have hives available for field trials. One of the strengths of the task force is that we are capable of doing large-scale experiments that cover different geographical regions, and such a research gives a great value. This was briefly the state of the art of Varroa Control Task Force. New members are welcome. We are also looking for beekeepers from as many countries as possible interested in CSI Varroa. For any questions, ideas, or suggestions, feel free to contact chairs of the task force, Victoria, Fanny, or Marin. Thank you all for your attention.
All right. So invite Marin and Vicky to unmute yourselves there. So you have a few questions. There's a lot of work done in Europe as well as through your task force regarding like brood interruption. Can you go into a bit more detail on the types of ways that you can elicit brood interruption and how you can consider like the practicality of it for different types of beekeepers, like whether or not you've got 500 colonies or 5 colonies? There might be a practical aspects there. And how do you like sort of target your research?
Hello, everybody. First of all, Vicky, I may go with this question, if you agree.
Yes, of course. Okay. Of course.
Well, in this research, you can find it easily online. And in this research, we look for all aspects, including what is time necessary to perform all activities. So we conclude, for example, that queen caging with the 4.2 oxalic acid application afterwards works quite effectively, and it takes about 20 minutes to perform all necessary tasks in this methodology. But for example, there are other methods like complete brood removal or the trapping comb techniques, where this is for those beekeepers who are interested to use pure biotechnical methods. They don't need any chemical treatment afterwards. So every beekeeper, be it either a big beekeeper with several hundred colonies or just a small-scale beekeeper, can find easily in this research all data that he necessary, so he can decide on which method he can use.
Okay, great. I've got another question from one of our US colleagues. So at least here in the States, and maybe it's the case in Europe, I'm not sure. We don't necessarily have to give an answer to this, but some beekeepers are relying on Varroa control measures that are not, I guess, regulated or allowed to be used. So does the Varroa Control Task Force evaluate like common methods by commercial beekeepers that may not employ like a registered product in Europe? Is that the case?
Okay. At the moment, we are not evaluating, or we are not planning to evaluate such methods. There is a big difference, for example, in treatment of colonies between the north of Europe and south of Europe, and probably in the southern part of Europe, the situation is similar, like in the United States. But we are not testing, let's call this illegal or not registered products.
Mm-hmm. Okay, thank you.
May I add something?
Yes, please, Vicky.
What we are actually doing now in the monitoring group, we ask about what kind of methods people use, so we can just get the idea of what chemicals they use. We are not exactly asking them if they are asking the legal products or not legal products. So I think there we can get the idea what they're using. In CSI Varroa, we will again give them a possibility to answer what they are treating. So I think it's important to know what kind of methods people are using. But it's clear from the preliminary results that Alison Gray from the monitoring group presented that there is some, Marin said, there is a very big difference between the northern countries, which have less, it seems, of a raw problem, because in the northern countries you have a winter break and the varroa is less of a problem than in the southern countries that have varroa all year round, and then the pressure is much, much higher. So I think the urge of the beekeepers to go for non-organic treatments is much, much bigger in the south.
Okay. Yeah, well, that's certainly like a limitation when a lot of beekeepers are using products or application methods that haven't actually been thoroughly tested. So that's certainly a challenge for the industry. And interesting that you said the difference between North and South in Europe, because it's actually the opposite in the United States. So yeah, we're diving into that ourselves here. So regarding CSI Varroa, there was one question. Do you plan to make a distinction between the economic injury level and the economic threshold?
Unfortunately, I think this should be a question to Fanny Hajina, who is really in charge of this project.
Okay, so we'll let Fanny, I see Fanny's in the chat. How about we let Fanny respond to the chat, in the chat box for everyone there. Yeah.
But so I might just comment that it's very difficult to differentiate those, because it's very much dependent, again, on the chemicals that the beekeeper is using. Because if he is using something very fast and some like synthetic chemicals, then he can allow maybe higher threshold. Mm-hmm. While if he's using something milder, it obviously will result in a much lower threshold. Yep. If you see what I mean.
Because yep, perfectly. Yep, the knockdown.
And I don't think we can really see it, but Fanny might answer better.
Okay, great. Thanks for that, Vicky and Marin, and we'll let Fanny respond in the chat to that. So we're going to keep on rolling and move over to APA Talk. So take it away, Jack.
Bye.
Good morning, good afternoon, or good evening, depending where you are, from where you are attending to this conference. My name is Noah Simon, and together with Piotr Meczyki, we are coordinating the task force APITOX. That is a task force within COLOSS that is dealing with bee ecotoxicology. So both the exposure of bees to pollutants and the effects that these pollutants can have on bees. So I'm going to present you today the state of the art of our activities, let's say, in the last year. And yeah, but then first I would like to present you what is the nature of the work of the activities that we do within APITOX. So first, we are there to share data and information because all of us participate to different initiatives or different working groups or things like this. So we gather information that we think that it is important for the other members. So then we share it within us. We also develop relevant methodology for the evaluation of the effects of pesticides on bees or possibilities of exposure of pesticides to bees. Or finally, if we put these two together, so the exposure and the effects, we also participate to the methodology for evaluating the risk of these pesticides on bees. Within us, we communicate our results when we consider that we have results that can interest the work that we know other people within the group are doing, and then we also participate to the process of risk assessment. And for doing that, we participate as experts in expert groups, consultation, etc., to provide our expertise on the matter. So if we go to the activities that we have done in 2019-20, the most positive one and the first one is that we have 3 new members. Daniela Gosar, Katia Martins, and Gennaro Di Prisco. These are the three young scientists that joined us, and it's very nice because it's making our group a little younger. So now we have the old experienced ones together with the young, and it's an explosive mixture. We hope that everything that is going to come out of this is very positive. What we have also worked a lot is on the engagement with institutions, and specifically the EFSA, so the European Food Safety Authority. We, as Apitox members, already participate to expert groups or to consultations or to different institutions like OECD as well, developing methodology. And in 2019 and 2020, it has been a year in which the European Food Safety Authority is reviewing the guidance document for the risk assessment of pesticides on bees. So in this procedure, in this review, we have, or some of us, let's say, have participated in reading the documents that the EFSA has proposed and submitting reactions or comments, if need be, to the methodologies proposed. And what is important to say is that the feedback that the Apitox members have provided have not been given as COLOSS, because COLOSS cannot be registered as a stakeholder for the EFSA because it is registered in Switzerland. So since it is not a European member, let's say a European Union member, COLOSS can only be an observer, and therefore our feedback has been done through other organizations that were registered members. So, and for the projects that we have developed, so we have a pesticide degradation project that we did already in 2019. So actually we tried to ring test this project, but we had a problem, and that's actually the nice part of ring test, because it makes you realize how difficult it is to do things in the same way. So actually from the failure we had, something very positive came, which is actually some practical recommendations for sample handling if they are going to be for pesticide analysis. You have them here, and anyway, these recommendations will be updated in the website of COLOSS in the section of Apitox, so that everybody have them available if they need to send samples for analysis and they want to have some results. The second project that we have is an old project, actually. It's one on hypopharyngeal glands. It has been running for quite some time now, and so what we try to do is to ring test the methodology for the evaluation of hypopharyngeal glands, because we see that the impact of pesticides on hypopharyngeal glands could have a potential as a sublethal effect assessment. So in this project, what we try to figure out are actually the parameters that may affect the hypopharyngeal glands development. Also, we try to compare different methodologies for evaluating hypopharyngeal glands, so either measuring the diameters, or measuring their protein content, or measuring the weight of the head, and maybe other methodologies that could come available. And what we also try to do is to try to make the connection between the observations done in the lab and the observations done in the field. So what we have done in this project is actually to do this lab to field comparison. And what we have also done is to evaluate what is the variability that we can observe in the measurement of the diameter of the hypopharyngeal glands. And we have seen how much this, how big this variability is. So as a result, we have 2 publications that are in the making, and a proposal for a protocol to evaluate different measurements of hypopharyngeal glands. What we have also done is that we have done the measurements regarding the time that the samples can be in the freezer, and actually evaluate if a long time that the bees have been frozen affects the size of the hypopharyngeal glands. The third project that we had is the time to death approach on honeybees. So the objective of this project was to ring test a methodology that actually exposed the honeybees during their lifetime in a lab to a pesticide, and then we see what is the impact on longevity. So we have performed a 2-year ring testing. There were 9 labs involved from 6 different countries, and we have now finalized this project. And the work has been submitted to publications. So we have drafted the publication, let's say, and it has been submitted to publication, and it's now under review. So the fourth project is the same one as, let's say, for honeybees, but on solitary bees. And here, so what we have been working this year is on the protocol. So define the protocol, try to reduce or to explore the different parameters that could make vary the success, let's say, of the protocol. And we can now say that the protocol is ready, and it will be launched in spring next year. And then finally, we have the project on the honeybee background mortality. So this is a project that has a fundamental science approach, in which what we try to do is to establish the basis for the physiological mortality that can be observed in natural conditions on the honeybee colonies whenever these colonies are not stressed because of whatever, like beekeeping management, or the weather, or the pesticide exposure, etc. And then based on this basis, then we can explore if we can define some levels that could be pathological. So in order to do this, we have 2 approaches. One is the experimental one, in which we are going to use RFID microchips. And then the second one is a citizen science, in which we are going to use electronic devices like bee counters. So the first one, the experimental, the protocol is ready, and we are funding for research for funding. We are researching for funding because it is very cost intensive. And if we find this funding, we hope to launch it next year in spring. And then the second one, the citizen science approach, it's on hold because we depend on the development of third parties. So we don't really know when this will be able to be put in place, but we don't forget it. So it's on the pipeline, let's say. And with this, I finish. I thank you very much for your attention. And if you have any questions or comments, please write either to Piotr or to me. Bye.
Okay, so I'll ask Noah and Piotr to unmute. We've got a few questions coming in from different channels. I'm trying to toggle all my screens here. So can you describe what a ring test is?
Piotr, you want to go or I go?
Okay, good morning, good afternoon. Let me work the video. Okay, what a ring test is? This is the question.
Yep, exactly. Can you describe in a few seconds what a ring test is?
Okay. A ring test of a method, which doesn't necessarily mean a method in ecotalks, is an initiative to try to perform, to apply the same protocol, which is in the process of ring testing, of validation, to apply this protocol exactly in the same conditions and with the same parameters, but applied by different labs, possibly located in different countries or continents even, and climatic zones, like things like that. And the objective of the ring test is to compare the results obtained by the different labs while they apply the same protocol. If the results, let's say the LD50 of a certain substance appears to be the same, I mean, with no significant difference between the labs, this means that the protocol is valid, reliable, and repeatable. And we obtained this conclusion through the ring testing.
Can you describe maybe what's a large challenge to performing or like successfully performing a ring test or validating a new test? Like what challenges do you face?
Many.
Okay, please, yeah, if you want to answer.
So, I mean, you think that the protocol that you have done is super simple and super easy to do, and then you give it to the other people, and then they start understanding what you have written in a different way. So then you need to be, then it teaches you that you need to be very, very prescriptive into the, let's say, the instructions that you give. Sometimes up to the point of what is the race of the beads that you can use, or what is the type of tubes that you have to use, or the syringes, or the conditions. No, so actually you don't really know what you're going to face as difficulties as when you launch into the exercise, and then you start discovering,
problems, challenges, yeah.
Yes, from new approaches to research.
Yeah.
Yeah. So.
All right, thanks, Noah, for that. So one final question from the Zoom chat, maybe you've seen. So Liz is asking about imidacloprid. It's restricted in many places now, and I guess speaking to it as kind of like a model pesticide to be studied, as well as one that was previously widely spread. Is there like a new, let's say, model pesticide on the horizon that that Apotox and maybe other groups should be focusing on?
Well, yeah, I think, I mean, when we try to be also creative and vary our, let's say, with the products. So we keep on using some neurotoxic ones, but now there are in the market coming some myotoxic. So these are products that affect the muscles, so the muscle construction much more than the neurosystem. So I think it is also interesting to use different modes of action to see how the bees react in a different way or not. But yeah, I think it would be interesting to take different active substances with different mode of actions, and then see how they react.
Okay, great. So there are a couple questions in the chat that we're going to leave that to you. One from Fleming about what type of bee counter do you use, and then there's also some questions about hypopharyngeal glands. So I'll let Piotr and Noah address them in the chat box. So, all right, thanks very much, Noah and Piotr, and we're going to turn our attention to nutrition now.
Thank you.
Hello everyone, this is Simone Tosi. I am one of the coordinators of the Nutrition Task Force in COLOSS, together with Michel Bouquet. This presentation that I will give is about the state of the art of this task force. Today I will provide a brief overview on the Bee Nutrition Task Force and its short history. And I will also address quickly how it works in terms of projects, in terms of working groups, funding, and what we know about next meetings. The Bee Nutrition Task Force was proposed in 2019 by myself and Michel, and it was formally started later that year in Montreal, Canada, where we had our kickoff meeting at the 15th COLOSS conference. The Bee Nutrition Task Force is basically a network of experts in bee nutrition, where bee nutrition is defined as a major driver of bee health, as well as a common beekeeping management practice. In fact, you may know that beekeepers typically feed their colonies in certain periods of the year with specific types of food to sustain the health of the bees. The Bee Nutrition Task Force aims at fostering discussions and collaborations. We want to keep updated on the state of the art, on bee nutrition, on the scientific advances, and we want to develop harmonized and standardized research on bee nutrition, with also the final aim to produce scientifically sound outputs. We have now a wonderful website. You should go to coloss.org, and from there you should go to what we do here, and then task forces, and then nutrition. At our task force webpage, you will find information such as the description of our task force, as well as the link to submit your membership request. And you can find other information there too. We have 91 members in the task force, and you can see their names inside the flower on the right. However, if you don't like art, you can find a much more readable and clear but boring list of members also on the website. On the bottom left, you can also see a couple of photos that we received from members. The first time we had the opportunity to meet in person was last year in Montreal, and it already seems a long time ago. Over there, we had the opportunity to get to know each other a little bit better, and as I said, it was the first time we met in person, and it was interesting, especially the outcome of a brainstorming exercise that we did. Basically, that was aimed at screening for the members' expectations and interests towards this task force, and also to develop and identify which topics this task force should investigate, and also what are the main characteristics that this task force should have. We defined that the Bee Nutrition Task Force should target some key stakeholders, which are beekeepers, the academia, and consumers. Indeed, there are other stakeholders that we are internally discussing to include in this list. And furthermore, we should communicate indeed and have an outreach activity, which should mainly go through publications, social media, and newsletters, such as the COLOSS one. Together with the task force members that were present at the previous meeting, we performed an interesting brainstorming exercise, which was aimed at identifying the possible lines of research that we could pursue, and also at having an overview on our expertise and interests. This is a brief summary of our discussion in the form of a mind map, and you can see that that we can investigate the methods that are used to study bee nutrition and focus on harmonization and standardization. We can use monitoring approaches and use thus, for example, questionnaire techniques to investigate the beekeeping management practices related to bee nutrition. And of course, we can investigate through research activities how nutrition alters bee health. And of course, many other possibilities arise, as well as many possible projects. There were several proposals at the previous meeting, and we are currently discussing which one are the most interesting and feasible and relevant. And thus I won't talk much about it, but I will as soon as we define the specific projects that we decided to pursue. This task force faces challenges, which are also great opportunities. As I mentioned, bee nutrition is a vast field. There are many topics that are extremely interesting to investigate. And also members have a variety of expertise. In this framework, the Nutrition Task Force needs to facilitate the exploitation of our expertise. It needs to foster networking and collaboration. Basically, we need to get to know each other better. And doing so, developing projects will help. The projects that are developed need to be relevant, they need to be scientifically sound, and they need to be feasible without funding, at least for now. Although our task force was recently formed last year, we already have several projects under discussion. We are eager to let you know more details about them once we have reached an agreement among the task force members on which projects we will pursue. In the meantime, we are still accepting new projects. So if you have ideas of new projects that can be suitable for this task force, please let us know. We are in the process of creating working groups. Each project will have a dedicated working group, which will allow to have a more focused activity towards specific goals. Of course, each working group will have different members, which will be volunteers, and they will be members of the Nutrition Task Force, of course. Indeed, updates from each working group will be periodically shared to all task force members and to the COLOSS community. And this is to strengthen the interest in being transparent and open. Of course, funding. We just started and we're in the process of developing projects, and thus we haven't got any funding yet. But we are interested, of course, in obtaining funding, and we're working on it. Indeed, suggestions are very welcome. We are also discussing about the next meetings. For sure, what we know is that the next meetings will be virtual. That's unfortunate, yes. Anyway, we will have two types of meetings. One that is dedicated to each specific working group. These will happen more frequently and will address topics that are specifically designed for each working group. And then we will have also meetings open to all members of the task force. Further information about the specific dates and all the other information will come after we discuss with all members about these specific topics. Thank you so much for attending this virtual presentation. We're happy to answer any questions and to hear any feedback that you may have. Of course, you can go to the website too. There are various informations there. And if not now, you can reach out to us in the emails here below. And I hope I will hear or I will see you in person or virtually soon.
All right, Simone, if you don't mind unmuting. I think Michelle is not with us this morning, so it all rides on you. So there is one question, I guess, regarding like the current kind of COLOSS membership. And in the past, COLOSS hasn't necessarily focused in on broader ecological questions or approaches like landscape ecology and GIS. And as like a new task force dealing with nutrition, do you have any plans to, like, let's say, target people that might not be a COLOSS member right now to see if we can kind of bolster that area? Or maybe there are individuals there that you can reach out to or have already reached out to you. But I guess the idea is to, yeah, like, I guess broaden our approach, because frequently beekeepers are losing colonies because of possibly poor nutrition. So I'll throw that over to you, Simone.
Yeah, thanks. Can you hear me?
Yep.
Okay, good. Yeah, so that's a great point. So we started the discussion, and we had a workshop a couple of weeks ago, and we have developed some projects that will be listed in the presentation tomorrow. So I welcome everybody to follow the presentation tomorrow. And of course, land use and the land cover is very important for nutrition, and indeed we've been discussing about it. And we also aim at developing a kind of network where we have also location of apiaries and then connect, the results, any type of results like mortality or quality of the nutrition of the hive to the land cover around. But of course, that's very initial stages, and we would be very happy to involve specific members of the task force or reach out to someone else.
Okay, thanks for that. There's a question coming in from some beekeepers regarding like a lot of supplemental food on the market. You go to like a bee conference or a bee show and you can buy, several different types. Is there any opportunity for COLOSS to like independently vet those supplemental foods?
Yes, of course. So this is also like a complex question, because it's not just because it's about testing the type of food and evaluating what is eventually the best one that we suggest. And that's not been easy. There's many studies out testing different types of food, but the evidence is often not clear. But indeed, there's something that we should do. And considering that we have many partners from different countries, it would be great to, for example, perform a ring test that, for example, Piotr explained before, or something that involves multiple labs to test different types of bee food and see what would be the results. Indeed,
is there any opportunities to? This is another question coming in through Zoom. So not necessarily testing an existing product or products, but any opportunities for COLOSS to develop its own bee food, for example, like the Nutrition Task Force?
Yes, of course, that would be like a very interesting idea. I believe it's not easy, but that's something that we will add to the agenda next time.
All right. Okay. Thanks, Simone, so much. Just looking over to the schedule here, I think that puts us at another 15-minute break or so. Well, let's take 13 minutes. So Jack, if you want to roll through to that break slide. I just want to point out that we've got 139 people on Zoom, and then I'm just having a look over on Facebook. We've got about 111 right now. I saw upwards of 130 before, so really happy to see everyone participating. So yeah, take a 13-minute refreshment break, and we'll see you all at 1:15 the hour. All right, everyone, welcome back from your break. We're going to fall into the final segment of today's COLOSS conference, getting more state-of-the-art presentations from several of our task forces. So next up is bee breeding. So take it away, Jack.
The Research Network for Sustainable Bee Breeding is a task force within COLOSS, which currently includes 49 members from across the whole of Europe, but also from Turkey and from Canada. With this presentation, we want to provide you with a brief state of the art of the topics that this group of scientists is focusing on and shares as common aims. The basis for sustainable bee breeding is recognizing that variation in honeybee populations across the native range does exist, and that this variation is a precious resource not only for survival of the Apis mellifera species, but also for successful beekeeping. Indeed, several studies, also carried out within this group, have shown that honeybee populations are adapted to their environment of origin, and this has effects on their performance and survival, and thus an added value for beekeeping too. For these reasons, the group aims to develop approaches towards selective breeding as a means of conservation of natural honeybee diversity, because beekeepers have a strong impact on honeybee populations. Furthermore, we believe that as scientists we should offer beekeepers with tools to select bees that are better able to cope with parasites and other stressors, and for this reason we have been searching for and evaluating relevant traits. Within the task force there is expertise on methods to characterize and discriminate subspecies, which were compiled in a specific bee book chapter. Methods in use range from traditional morphometrics to modern SNP chips. Efforts of several task force members, either in individual or in collaborative projects, have led to new insights of the status of honeybee diversity, mainly across Europe. One example of such a project was the Smart Bees project, which had among its aims the assessment of the status of native honeybee populations. To characterize variation across the European range of the species, and with the help of numerous colleagues from the group, honeybee samples were collected from populations between Ireland in the west and Russia in the east, and from Malta in the south to Scandinavia in the north. The sampling achieved in this project covered several regions that were for the first time subject to scientific research. The collection will also serve as a valuable reference source for future research. The samples were subjected to pooled sequencing and, based on the sequences, SNPs informative for lineages and subspecies were identified and validated with independent samples. A diagnostic chip containing more than 2,500 SNPs was developed and now offers a reliable, fast, and economic subspecies diagnosis for unknown samples. It is currently limited to European subspecies, but can be expanded in the future. A first publication about this project has recently been submitted. A large-scale study conducted within COLOSS, the so-called GEI experiment, in which colonies of different genetic origin were tested in different locations across Europe, so that they were all either local or non-local, showed that colonies of local origin survived longer under stressful conditions. In this review, we highlighted how resistance traits seem to lose effect when the genotype is transferred from its area of origin, and hypothesized that different populations may have developed specific resistance mechanisms suited to the challenges present in their environment of origin, which may not be as effective in different environments. One of the aims of this task force is to provide beekeepers with tools to protect and improve their bees. There is now higher awareness among beekeepers of the importance of using local stock and of including resistance traits in their selection criteria. Within this task force, we developed a protocol for screening the suppression of mite reproduction trait based on experience of task force members and on work by American colleagues. In this recently published paper, we present the results of application of this protocol in 13 different countries, encompassing 9 genotypes. The study served to validate the protocol for its use in further surveys, as we found that a minimum number of 35 single-infested cells need to be investigated for the SMR value to be reliable. We showed that the trait is present across European colonies belonging to different subspecies and races, with high levels of variation. The potential for use of SMR as a selection trait is also provided by the higher level of SMR in colonies that were selected for this trait as compared to non-selected, as you can see in the figure. In addition to hygienic behavior targeted towards varroa-infested cells, also known as VSH, where worker bees open and remove infested brood, there is also the so-called uncapping and recapping behavior that is less costly for the colony. Here, worker bees just bite a hole into the cell capping, but instead of removing the brood, they rapidly close the opening again. Nonetheless, this behavior has been shown to significantly disturb the reproduction success of the mites. In this publication, in which members of the task force were involved, it is shown that four different resistant honeybee populations, the recapping behavior is not only more frequent than in mite susceptible ones, but also that it is significantly more targeted towards varroa-infested cells. One conclusion is that this behavior contributes significantly to limiting mite reproduction success in resistant populations. What are the best traits to consider to select for varroa resistance? The best trait would be colony survival in absence of treatment, and indeed there are some breeding programs based on this. However, not many breeders are prepared to face the initial losses that survival tests entail. Instead, selective breeding for varroa resistance can be based on differences in mite infestation and specific behavioral traits, but these need to be repeatable to ensure that they are reflecting a characteristic of the genotype rather than an environmental effect. In this big study of performance data from the Carnica database, almost 500 colonies and 4 seasons, Ralph and colleagues found that bee infestation in summer, adjusted for the level of natural mite fall in spring, is a suitable trait for varroa resistance, and also suggested including brood infestation rate and the increase rate of bee infestation in summer. Brood hygiene and recapping were also found to be characteristic colony traits, while SMR was found to be very strongly influenced by environmental effects, so at the moment it should be used cautiously in combination with other traits. In general, authors make the consideration that to achieve a successful selection progress, heritabilities of the traits and their genetic correlations should be calculated, and reliable models for breeding values must be elaborated. Members of the task force are currently engaged in a variety of projects on the international and national level, with the aim of promoting sustainable breeding efforts. These include large-scale evaluation studies on the European level, as for instance the Eurobest project, a study promoted and funded directly by the Agriculture Directorate of the European Commission, and an international study conducted in Southeastern Europe, focusing on selection and conservation. There are, of course, also national selection and conservation programs ongoing in most of the countries represented within the task force, which provides a platform for involved scientists to exchange ideas and to cooperate. Thank you for your attention.
All right, so I'll ask Marina and Cecilia to unmute themselves. Okay, a few questions here. So there's been a lot of work done on like breeding for resistance or tolerance to Varroa specifically. Do you think that that's successful from like an industry perspective right now? And if not, like what are like the main barriers or hurdles that we need to overcome to allow like the beekeeping industry to really adopt these bees in the long term?
Hello.
Hey, Cecilia.
Hi, everyone. So one of the studies that we mentioned at the end of the presentation, and which we presented during our workshop, in which several task force members are involved, does aim at understanding how breeding for resistance can be promoted among breeders, and how the use of resistant bees can be promoted among beekeepers. So what do beekeepers need to be encouraged, and is there an interest? And so what we are seeing is that there is a great interest and awareness. It seems awareness is increasing. In the study that we conducted, we found that actually there are not many resistant bees actually available on the market, and often they are advertised as resistant, but it's not clear whether they are resistant or not. And one thing also that we have been investigating, following also the COLOSS experiment of genotype environment interactions, is does this resistance stay? How much is it influenced by environment? And it seems that it is influenced a lot. So that is why we are trying to promote breeding, including resistance traits in local breeding strategies.
Okay, great. Thanks, Cecilia. Another question coming in from a beekeeper, and you kind of touched on that, is are there ways that a beekeeper can sort of identify a trusted source of queens, for example? You know, do they, I guess, contact local beekeepers? Is there any kind of network, or can COLOSS, for example, certify breeders or something like that? So is there ways to identify a trusted source of bees, or is that an opportunity?
I think in the study that Cecilia just mentioned, the Eurobest project, we are addressing these issues too. And I don't think we have something like general criteria available right now that would allow us to judge a source or to evaluate different sources. But we started in kind of compiling a market overview, right now focusing on Europe, but I think once we have the methods, we can expand that, and then we could work our way towards an evaluation system and a judging system of queen sources and breeding material sources. So really, when we started this, we had to face the difficulties that really there weren't very many data available, and we really had to kind of reach out to colleagues in many countries and see what they could contribute.
Okay. I've got another question. Yeah, go ahead, Cecilia.
One practical advice, I mean, for a beekeeper could be to ask the breeder what trait did they use to select the bees, what kind of selection process did they follow, and do they have any records of this? And there are some platforms on national or international level in which evaluations are recorded and breeding values estimated. So in some cases, breeders can give some proof that they have done some work. So, I mean, this can be a very practical reply to a beekeeper now, that there aren't any, let's say, internationally recognized standards or certification bodies, but breeders can in some way prove that they have performed some selection in this sense.
Okay, great. There is one comment about the large need for that, but I'll let you both address that. So one quick question to squeeze in here. Are any resistance behaviors more dominant than others, especially regarding like outbreeding, resilient to outbreeding? So are there any resistance behaviors more dominant than others?
Well, the study that we showed at the end of the presentation by Ralph and Büchler and some other colleagues, they were trying to assess which traits are more useful in a breeding program, and so which ones show greater repeatability and which ones are less influenced by environment. So yes, studies of this kind of assessment are underway, and of course we do need larger data sets to be able to understand this.
Okay, thanks, Cecilia. All right, there's a few things going on in the chat box, so feel free to take a look at them, but we're going to move on over into small hive beetle. So thanks, Marina and Cecilia, and Jack, please hit the play button.
Good morning, good day, good evening, depending on the actual time zone. It's my great pleasure to present today on behalf of Braunmark and myself the state-of-the-art small hive beetle biology and control. First of all, I am truly delighted that there has been an increased research effort on the small hive beetle. In 1997, when it became an invasive species, there were just 5 papers. In 2014, when it arrived in Italy, there were 150, and now we had 186 papers published last year with Tina Tomita and Google Scholar. So that is great news that there is an increased effort. Nevertheless, there are still major gaps in our knowledge. And so here I will just give, of course, a brief overview on some highlights within the short presentation. The life cycle of small hive beetle, here it is. Adult small hive beetles invade strong and weak colonies with equal impunity. Within the colonies, males and females mate. The males lay eggs. They prefer small cracks and crevices. Then these eggs are hatching. The larvae, once hatched, they feed on all possible food in the vicinity. And then they reach the wandering stage, the post-feeding stage of the larvae. They leave the nest for pupation in the soil. For that purpose, they dig into the soil, they make a pupation chamber, and then, depending on humidity and temperature, the adult beetles emerge from the soil and close the life cycle of the small hive beetle. Important part in Africa is so-called absconding. This is, disturbance-induced. The colonies are leaving their nests, and this is not reproductive swarming. And in Africa, this mass reproduction with many, many larvae is usually restricted to such after absconding events, and the nests are abandoned, not defended anymore. Otherwise, we have in Africa only low-level reproduction, which is not damaging the colonies. So this picture here, taken from a European-derived colony in the United States, a clear classical mass reproduction of small hive beetles, where often thousands of larvae are occurring, and this is very often resulting in this complete destruction of the entire nest. And even strong colonies of European honeybee subspecies, for example, like about entertain frames, can be destroyed within less than 1 week. Another thing which is worrying is here eastern honeybees, Apis cerana. We had reports that in China, these bees appear to be susceptible hosts. So this is creating demand to understand the impossible impact of small hive beetle on other species of this genus. Here's a nest of bumblebees. We also know for quite a while now that they naturally infect bumblebee colonies in the field. Here are pictures of small hive beetles in stingless bee colonies causing damage. And also quite recently, we also know that nests of solitary bees can serve as a breeding ground for small hive beetles. On top of that, these beetles are really opportunistic. You can see on the left the beetle foraging on a flower, and they can also use, for example, fruits, here bananas, as a breeding ground, which is of course a much cheaper option compared to frames in the laboratory. So it's very safe to say that these are opportunistic parasites of bee nests, possibly with a wide host range. While the impact on managed honeybees Apis mellifera is known, we know very little for wild hosts, almost only anecdotal reports. And here there is a great demand to understand the smaller beetle impact. Now, welcome to the Smaller Beetle World Tour. Here in the gray area, you see the endemic range of smaller beetle in sub-Saharan Africa. In 1996, a beetle was first reported in the United States. And since then, quite a number of introductions have been reported from across the world, quite recently here again in 2 provinces in China. And now it is safe to say that the smaller beetle is now established in all continents except Antarctica. It's always good to know the origin of a smaller beetle to find out transmission pathways to limit at least its further spread. So what we did here in the study, we used genetic data, and we were able to confirm previous findings, suggested a couple of new ones. Here in the dashed lines show unclear whether beetles are originating actually from South Africa or Australia and Hawaii. So all these are correlations, so it would be good to make that stronger. And what we did is now a completely different data set. That is the FAO data on beeswax trait, and we plotted those over the genetics data. And what they were showing is here a match. If we exclude the one case here in 5 in Portugal, there was a clear sign, very obvious, the smaller beetle was introduced with the queen packages, and for Hawaii, there wasn't FAO data available. In all other cases, genetics and FAO data on beeswax suggest the very same source. So we have all reasons to believe that global trade of beeswax is a major transmission pathway and should be addressed in the future. These pictures here, again, they are fairly uncommon in Africa or rarely seen. The left one is from Paddy Alston in the US, and the right one is from Michael Duncan in New South Wales, Australia. This mass reproduction, there is a different impact in the invasive range compared to Africa. Excuse me. So the differential impact of smaller beetle is probably due to quantitative differences between African and European derived honeybee hosts in a whole range of behaviors, from aggression over exconding efficacy. Climate can play a role, animal release, and or alternative hosts. So one is very good news over here is we have now the smaller beetle genome is available. Personally regards this as a major research tool that will help us much better understanding the fundamental biology of this species. Coming to diagnosis and control, there have been quite a few traps have been invented on the bottom board, in between frames and the lids, and so on. And here you will see the movements. All the best lure, the best trap is a functional colony. That's all we know. So the beetles get in there, and then they are trapped within those traps. Unfortunately, we have very few data about the efficacy of those traps, and comparing here, there's a real need to address those. Coming to diagnosis and control, environmental traps outside of colonies. There have been a couple of essays has been done, but here's also a need to improve those, for example, pheromones. And we need alternative soil treatments. By treating the soil with insecticides is not environmentally sustainable and also not very helpful if we want to do beekeeping. So here is another trap with UV light. You can attract the beetles in the honey extract. Prevention is a key point. It's actually a key to sexual control. Here you can see pictures of thousands of wandering larvae in the apiary of the honey extraction facility. And good beekeeping practice is a first step, having good hygienic behavior at the colony, at the apiary level is a key point. Then the first line of defense is the border control. Obviously, before a beetle gets into a country, this is the best way you can have it. Then once it is there, establishing protection and surveillance zones is a major point. And sentinel colonies have been proven to lure free-flying smaller beetles that might have escaped eradication, and they have been also proven very successfully for surveillance and protection zones, for example, by surveillance in smaller beetle-free areas. We're doing that also in Switzerland. It's quite good because then you can really detect the very first introduction. You have a chance for eradication. Containment in infested areas is also recommended, and we have a couple of successful examples. For example, in Italy, it seems to work very well since 2004. So here we're having again an overview on the COLOSS network, and we need a feasible action plan for small hive beetles. So I'm really delighted that we have here our task force to avoid redundancy and instead foster mutual enrichment at a global level. That's a key point. So I'm very happy they work here together for a joint goal to get a better grip on this species. I would like to give a summary of my presentation. Small hive beetles are opportunistic African parasite of bee nests with a wide host range. It's a widespread invasive species by now, established in all continents except Antarctica. Damage to apiculture with western honeybees is known, but we have very little idea for wild bees. Small hive beetles follow the typical jump dispersal of any invasive species, and global wax trade appears to be a major transition factor. The differential impact of small hive beetles in native and endemic, in native and invasive ranges probably is due to quantitative differences between African and European-derived honeybee hosts in a range of behaviors. Climate, animal release, and alternative hosts are also likely to play a role. The small hive beetle genome is now available, which is good news. Then for diagnosis, in-hive and environmental traps are recommended. Control, also in-hive environmental traps and adequate fall treatments. Prevention and adaptive management is a key point, and a fast response to novel invasion has been proven very useful. Still, we have major gaps in our knowledge, which is essential for better control of the species. We should emphasize also fundamental biology to really tailor-make control and diagnostic efforts. And last but not least, we have a dedicated task force of COLOSS, and I'm looking very much forward for future joint collaborations. Thank you very much for your kind attention.
All right, thanks for that. Peter and Bram, I'll ask you to unmute yourselves. Okay, so we've got a few questions here coming in. So I guess, Peter, you mentioned in your presentation, you highlighted like some monitoring and treatments and control, so to speak. I mean, what's the prospects of being able to employ like a proper, more or less proper IPM approach with treatment thresholds and different tactics? Like, do you think that's realistic at some point in the near future? And is there any like low-hanging fruit for beekeepers to like try to employ an IPM approach?
Well, certainly, yes. Integrated pest management is absolutely important to do, but I do see here, there's considerable effort required. So we do that already in the task force, that we're going to evaluate the efficacy of certain methods. So we have a backbone, what really can be recommended based also in accordance, of course, with local practice. So yes, absolutely, IPM is quite important. There's been work done in the US by Mike Hood and others, and we need now to build up on that with a global effort of our collaborating people within the task force.
Okay, thanks. Next question. What's the prospects of eradicating small hive beetle from Europe? Is it possible? Are we past that point?
Bram?
Want me to take that one? Yeah.
Yeah, Bram, please go ahead.
I think we're way beyond the point where we can actually eradicate the small hive beetle from Italy. I mean, it's been established for a couple of years now with quite an extensive effort to eradicate it, and it's still there. And I think we will just have to deal with it. And I mean, they do a great job at containing it, at least for the region, in the region. But I'm sure that in due time, it'll probably spread over to other regions in Italy and probably Europe as well.
Okay,
yeah.
So kind of connected to that, and this is a question coming in from Facebook. Can you describe what a border control consists of? What does that mean? I mean, there's clearly no one checking passports at the Italian-Swiss border. So what is a border control for small hive beetle mean?
Well, I guess that depends on the country, first of all. Some countries put a lot of effort in it. They actually check randomly cargoes, which might be of interest, or areas that might be of interest. For instance, harbors, you can set up sentinel colonies and do regular checks of sentinel colonies for small hive beetles. But other countries don't do much and have only paperworks involved. So it depends very much on what country you're talking about. So, yeah.
Okay, great. And I see you addressed this in the chat, but just in case people aren't paying attention, can you describe how, I guess this is more to Peter, how that small hive beetle is transmitted via the wax? What's going on there?
Well, that's a good question. Yeah, it is. We have one case from Canada where I could hardly believe it that the small hive beetle moved with processed wax. So basically, small hive beetle is attracted to all kinds of different hive products and by odors, and because the adult females can live for like 2 months without any food. So they can make it with any kind of wax import, irrespective of the processing. So, processed wax was the least likely method but we found it. So I guess, there is a kind of a high number of cases where it just remains undetected. And again, here that the two correlations go in the very same direction, genetics and the FAO data. So I guess we should really think, within the task force, probably also European RefLab and others, sit together, how could we address the wax trade in a meaningful way? Because even if small hive beetle is now on many continents already, we should still limit its further spread until we have a better grip on the species.
Okay, thanks, Peter, and thanks, Bram. So we're going to transition over into another insect that's causing problems with honeybee health, and that is Vespa velutina. So Jack, please go ahead.
Good morning to everybody at the Velutina Task Force meeting. Velutina Task Force meeting was born in Slovenia, in Lukovica, in the October 2015. Here we have decided with the group to start with this task force to study the problem of Vespa velutina in the world. Until now, we were met 8 times in different countries. The kick-off meeting was organized in the University of Turin in Italy. We met after in another different place, in Romania, in the Balearic Island, in Greece, in Spain, in Belgium, other time in Italy, and in Canada. Unfortunately, for the virus COVID, it was not possible to organize the meeting in Coimbra, but we hope to do very soon. The last meeting was organized in Montreal, in Canada. We were in 20 members of Velutina Task Force from 12 different countries, from Belgium, France, Croatia, United Kingdom, China, Czech Republic, Slovenia, Germany, Austria, Greece, Holland, and Italy. In this slide, we can see a different picture of the group. We have always organized the Velutina Task Force meeting where we have the opportunity to see a nest and adults of Vespa velutina directly in the field. For each meeting, we have a book of abstract for who is interested. Now, I want to let speak Ivana Tlak-Geiger, that she is my co-chair from the University of Croatia.
Hello to everybody. Firstly, I would like to greet you all warmly from the Faculty of Veterinary Medicine, University of Zagreb from Croatia. And now I will proceed with the presentation with the practical demonstration of the removal of the initial and secondary Vespa velutina nests in Bilbao during our Vespa velutina meeting. I can say it was a really interesting and useful experience. The Velutina Task Force currently has 70 members of the COLOSS from the 20 countries. Vespa velutina is an invasive alien species that should be managed in agreement with the European Union regulation on invasive alien species. It was firstly introduced in the area of France in 2003, and from that initial invasion till today, Vespa velutina was spread to many of European countries. Till today, Vespa velutina was recorded in France, Spain, Portugal, Belgium, Italy, Germany, United Kingdom, and Holland. Also, Vespa velutina was first recorded in the wild in Luxembourg on 2nd September 2020, and currently there are 5 records. Main tasks of Velutina Task Force are investigation and description on how the legislation regulations are applied for Vespa velutina in all Europe countries. Also, the establishment of impacts and protocols to evaluate the impacts of Vespa velutina on honeybee colonies and the wild bees. Then, the prey spectrum of Vespa velutina. Also, the implementation of the control measures and investigating of which modalities are applied in the European countries officially and which measures by the beekeepers. Also, currently there is progress in writing of a bee book chapter on the Vespa velutina and updates to the public link where all contained all the materials of the Vespa velutina task force. So, what we are doing now? Currently, we are working on writing the 2 scientific papers regarding the Vespa velutina action in the Europe and towards efficient mitigation of invasive hornet Vespa velutina. Also, we are preparing the materials and writing and editing the B-book chapter about Vespa velutina. So I hope that very soon we will have the final drafts of these manuscripts. If you need some more information about this task force, please contact the leaders of this group. So my colleague Daniela Laurino from Turin or me. Thank you very much.
Okay, so I'll ask Daniela and Ivana to unmute themselves. We've got a couple of questions here. So you showed that.
Okay. Do you
Hi
listen
there,
me?
Daniela. Yep, we can hear you.
Hi.
So you,
okay.
so you all showed the.
Okay, perfect.
you showed
The
the
video?
current distribution of Vespa velutina. Is there any kind of like environmental features that we know about that may limit its spread? Like, do you anticipate it's only a matter of time to spread across Europe, or yeah, will some barrier block that spread? So to Daniela or Ivana.
So hello everybody, Ivana is there. So I'm
Hi, Ivana.
Yes,
Okay, Ivana, we're having some issues with your connection here. So maybe you want to turn off your video. Daniela, are you able to address that question while Ivana's getting set up?
Is it better now?
Yep. Give it a shot there, Ivana.
So firstly, I regards from Croatia, and you probably all know that Vespa velutina is not detected yet in our country, and it is present in the north of Italy in 2013. So we are very close as a neighboring countries, and probably some impacts of the basic geographical creatures like mountains or something really can slowly this spreading to the new geographical areas. So currently, last year, we start with some monitoring programs at, we can say, on micro locations of one region of Croatia. It's called Istria, very close to Italy, but we didn't detect any suspicious specimens. Also, I can say in front of the National Laboratory for Honeybee Diseases that for last years we have a few cases of suspicious specimens from different parts of Croatia, but never we get really serious suspicions. That all was European Vespra cabro.
Okay, thanks, Ivana. So just to note that Daniela has dropped off. So this is directed back to you, Ivana, again. What about the thoughts of including other species of Vespa into the task force and not just focus on Vespa velutina? Any prospects there, or do you think there's a need?
So probably will be in the future because I think we have a notification from Slovenia that they noted last year also the Vespa orientalis. So probably there will be need for spread that research part on the other fishes.
Okay. One final question. Yeah, can you describe some of the control products? So there were like some list of chemicals there, for example, on one of the slides. Is there something that's existing in other Vespa or Vespid species? And can you just sort of describe for the audience what they look like? Are they baits, for example?
So these eradication measures are very specific and very complex for Vespa velutina because there are some traps and there are some bites. They are contaminated with different kinds of insecticides, but they are not specific for that species. And that is the real problem because the other kind of animals or I don't know, insects or some other beings can be also intoxicated during the putting these bites in the environment. So currently there is some procedure to the most of the European countries regarding this removing of the nests, initial and especially the secondary nests, because there are special services. They must come twice because first time they are inserting some kind of insecticides in it, and after 7 days they came for physically remove that nest. So this is a real some procedure and it's often make some financial needs or problems because the owners of or people who calls for nest removal must pay for this. I think that there is in any country of the Europe some strict measures that are covered by these costs, some kind of ministry or something like that, and that's not a problem only for beekeepers because of this economic impact. So the fear and everything. So if you have lucky that Vespa came on your yard, you have to call someone to remove it.
Okay, so very quick final question here. I guess, do we know if there's differences in the reproductive cycle of Vespa velutina according to like the different climates, like north versus south in Europe?
No, there is no difference, I think, because there is nothing in the article that describes different type of life cycle.
Okay. Thanks very much, Daniela. Via
Thank you
Marco.
to you, and sorry for my connection.
Nope, no worries.
Sorry.
Okay, thanks, Daniela and Ivana. Appreciate your presentation, and we're going to switch over now to hear about our survivors task force.
Thank you.
Welcome everybody. My name is Raffaele Dall'Oglio, and altogether with colleagues Fanny Monde and Peter Neumann, I'm chairing the Survivor Task Force of COLOSS. This task force was proposed inclusion in 2016, following the usual bottom-up approach that stands in COLOSS. So some members proposed this to activate this task force because of peculiar interest in the topic, and enough members decided that to follow this task force. So the executive committee enabled this task force starting from 2016, and since then we had several meetings, both in standalone event like workshops or congress, like in Athens in 17, or we also met beside the main scientific event like EURB 8 in Ghent in 2018, or just before Montreal Apimondia Expo in 2019 during the COLOSS Congress. Why this task force was initially proposed? The idea was that the situation of European honeybee population was heavily threatened by the infestation from varroa mites, but at the same time, after several years of infestation, there were evidence published in peer-reviewed journal of surviving population. Surviving means more than 10 years without any mite treatment by means of natural selection. Those populations were in Sweden, still are in Sweden, France, Norway, and the Netherlands. And there are also published evidence that this period of host adaptation is responsible in reducing the reproductive success of varroa destructor. Thus, the surviving colony phenotype is a mixed component of bee genetic and adaptation to the environment, where for the environment, of course, I mean not only climatic condition, foraging resources, but I also include management, and I also include a different mite population or virus stressor that are present in that peculiar environment. So in the meantime, beside this published evidence, there is also some gray literature or let's say anecdotal reports of more surviving population. So the idea behind the Survivor Task Force was at first to identify and verify if more population of Western honeybee subspecies are present and that they are able to survive the mite infestation without treatments. And a second parallel objective, let's say more interesting from a scientific perspective, is also to investigate and try to understand the mechanism enabling colony survival in this population. So we started this task force and we started those two objectives in parallel. At first, the scouting was performed through an online survey that was published in several languages and also disseminated through beekeeping journals and through our website, through COLOSS website. And as you can see, this is the first question that we ask to participants. We are not interested only in managed colonies, but we also ask if they are aware about surviving colonies in the wild. Sorry. And later, we try to widen our horizon even more. So we received a lot of several answers, and several countries were involved in the first survey. We decided to establish a specific project under our task force as an initiative of our task force. This project is called Honeybee Watch. It is about to be launched in 2020, and the first year will be 2021. The idea is to activate a citizen science study to study not only the managed survivors colonies, but also to study the free living colonies. Right now, we managed to have an improved version of the survey, which is now available in Honeybee Watch website. We are exploring different partnership with the ongoing project, similar project that, and the idea is to centralize and standardize data collection to enable a large-scale assessment of those of the status of those free living colonies. As for the second objective, we started with a protocol that was initiated by our member Pierre Blaquier from the Netherlands and published as the Darwinian black box selection. The idea was to build our own survivors, so to have a untreated population following a strict protocol that of course can be adapted to local circumstances and local climatic conditions, so it can be run in several countries, but at the same time following some specific and standard trait to enable a comparison, and at the same time to keep a control group that was treated against Varroa and it was, let's say, managed as business as usual. And after several generations, the idea was to measure the differences between the control group and the selection group in order to see what were the mechanisms that were mostly developed in the selection group. This is still ongoing. And beside this breeding effort, the understanding of the biological mechanism behind tolerance is explored through different ring tests. We have some traits that are published, maybe peculiar of some population. For instance, here a publication from the Norway and another one from Ireland highlighting a specific trait. The first idea through the ring test is to explore the role of the environment. So to exchange this genotype, to standardize, let's say, the management, to assess what is the role of the environment on survivorship. And furtherly, we'd like to test for specific traits, also using the ring test and the power of large-scale assessment. Some traits were already investigated in some population, and the idea is to explore more of those traits and to, of course, to test them in several populations. Not only managed population, but where possible also in the wild population. We still have a lot of work to do. For instance, after the scouting of those colonies, we have to assign priority because, of course, we rely on the help of citizens, but we need to validate the real survivorship value of those colonies. And also we need to prioritize our field intervention because we cannot be anywhere, especially since this project is right now looking for fund, but thus far we have no fund to run these experiments. Additionally, the monitoring will keep on going, so the survey will be kept open, let's say, forever, to gather more and more data, more and more records on resistant colonies. Also, for the objective 2, we have some pending goal that we are already exploring. So we'd like to include some free nesting population. We'd like to include some Apis non-mellifera as outgroup, especially from Asia, where most of the genus diversity is present. We are also considering the idea of to include some naturally tolerant population, for instance, Apis mellifera scutellata and Africanized bees, hybrids with Apis mellifera scutellata. And finally, we are trying to set up protocol to test at a large scale those specific traits that might be related to resistance. This will be maybe some more easy and simple protocol because we'd like to engage also with beekeepers and citizens. This is where we are standing right now. Those first 3 goals will be mainly addressed through Honeybee Watch project, while the last goal will be primarily discussed within the task force as a scientific, as a main scientific goal for the next years. While I will leave you with our contacts, the website COLOSS.org with our web page survivors, and also the new website of Honeybee Watch. I'd like to thank you all for your attention. Thank you.
Okay, so Raphael, can you please unmute? And I know Peter's on the line too and participates here, so feel free, Peter, to also unmute. So we've got a couple questions. First up, how are you distributing your Honeybee Watch questionnaire?
Thanks, Jeff. Can you hear me?
Yep, loud and clear.
Okay. So basically, actually, the new survey has just been uploaded on the new website, Honeybee Watch. The idea will be to distribute them directly within, let's say, our network, within the task force, and also through those research partners that we mentioned. So the idea is to gather under the same umbrella also other associations that are looking at the same things or basically pursuing the same goals. And we also rely on their mouth-to-mouth for the spreading of the survey.
Okay, so 2 somewhat related questions. How can you describe, like, what's your definition of a survivor colony? Does it have to be living without treatment for so many years, for example? Yeah, what's your definition of that survivor colony? And did you take that definition from articles, or did you develop your own protocol there?
I can provide you my opinion, then maybe Peter can back up on this, since we spent several workshops on the definition of survivors. So basically our unit is the colony, our observation unit is the colony, so not only the queen, so meaning that if a colony can successfully requeen itself, it's still our survivor colonies. And we believe in the definition we have to address all possible management and treatments that can interfere with the let's say varroa biology and enable the colony to survive even without human intervention. Then we have to, let's say, also be realistic with respect to environmental condition, because there are some areas in the world that is quite, let's say, typical that at least a couple of years a colony can survive without no human intervention on the mite. Other area this is not possible, but at the same time we should rely on something longer and also a stable, let's say, population in the area, not only a single colony. So it's a more complex definition.
So Peter, here's your time to reaffirm or rebut what Raphael just said. Any statement on survivor?
I agree with Raphael. Well done, yeah, surely. Now we've discussed it many times, yeah. Well, definitely the unit is a colony. So any colony maintaining all functions which are enabled for survival. That includes, sufficient workers to have, thermoregulation in the temperate regions, brooding, and so on. This is a key point as a colony. However, we are also interested in at the population level, so that we're having a sufficient number of colonies to maintain that population at the end of the day. So yes, that's fine. And I guess that is something like which emerged lately as well. Raphael, sorry, I may carry on here, that touched on that in his presentation. Now we have expanded our task force on purpose to include the other species, to really understand, to maybe to be able to detect patterns which we can only see if we broaden our view. So that has given an amazing touch to the group, and I'm very happy that we have managed that.
Okay. There's a quick follow-up from Piotr, actually. Like a perennial existing like colony, so to speak, that repeatedly swarms, that would be considered a survivor. Is that true?
Yes.
Okay. Okay, because it's able to requeen itself, so to speak. Okay. One final question. There's a lot of beekeepers that try to take a more natural approach, maybe similar. Well, I can't say maybe similar, but somewhat like Thierry's work in the Netherlands that you highlighted. I mean, if a beekeeper is going to take this natural beekeeping approach and attempt to be successful, is there a couple conditions or requirements that they need to sort of check off to give them any like a hope of like working through this properly?
Well, of course, you also have to consider what are the local conditions, because somewhere in some countries, I mean, it's mandatory to treat for mites, so you cannot simply stop treating. So the first recommendation I would give is to check with your local authorities or with your veterinarians if you are in the condition to start working on at this level, and also to pay attention not to affect your neighbor's operation if you have some neighbors otherwise. And then, of course, I would say your baseline is your business as usual. So meaning that if you now are treating twice a year, maybe your first steps will be to go versus one treatment, and then try to see how your population will react to that, and try to improve generation after generation, trying also to control your mating.
Okay. I guess we'll have to end it there. Thanks, Raphael and Peter, for providing comments in that presentation. We are moving on to our final task force state of the art, and that is on viruses.
Welcome to the Virus Task Force State of the Art. I am Nor Chekhanovsky from Israel, and my co-chair is Anne Dalman from France. We have the active support of Orlando Yanez from Switzerland. Our Virus Task Force has about more than 50 members of different countries. Some of them you can see are European countries and other countries associated here that their flags are present in this slide. Why do we need a Virus Task Force? We felt when we met the new viruses were published in the literature that needed to be addressed. We also felt that it is important to have standards to assess virus diversity. And we need a better knowledge about the variability of viruses, of local strains, recombinant strains, what is their virulence, how we detect that. For that purpose, we formulate our objectives. 1, to update and compile the information for the bee research community. 2, to provide tools to allow comparative analysis across the globe. The Virus Task Force meeting structure is, we have first short presentations of relevant topics, we discuss them, we present our current tasks, we ask what are the burning questions that we need to address, then we elect the VTF immediate tasks. Finally, we ask who is willing to host the next meeting and to organize it. We had our founder meeting in April 2017 in Avignon, a second meeting in February 2018 in Warsaw, and the third meeting in March 2018 in Halle. In between those meetings, we had a meeting in Athens in November 2017, in Ghent in September 2018, and in Montreal in September 2019. These 3 meetings were in parallel to COLOSS meetings and the Montreal meeting to the Aprimondia meeting. The topics we addressed following our objectives are virus variability, which is a problem for detection and assessing virus prevalence of most common viruses. And then it is important to design a sampling strategy to study virus variability and define adequate detection protocols. New viruses. Are symptoms the unique criteria to measure viruses? What is the seasonal prevalence of those viruses? What are the loads of those viruses? Are they transmitted and replicate, or are just passenger viruses? New viruses that are discovered by bioinformatics, what is their relevance to be held? Which biological assays should be used to measure viruses, prevalence, virulence, etc.? And how we collect in a uniformly way and transport our virals and our B samples to detect viruses. With our topics, the associated talks of that are presented over here, and as you can see, there is a large list of speakers that attended the workshops and provided information that was very important to discuss the different topics we were addressing. Regarding variability, questions and tasks. As I said, variability is a problem for virus detection and for assessing virus prevalence of most common viruses. What do we measure and what do we want to detect? We decided to concentrate, for example, on the found wing virus variability. We also decided to review the virus distribution and prevalence in different countries, the host-related patterns, the genetic variants, the phenotypic variants, virulence, and geographical variants. Regarding the found wing virus variability, there are so many primers in the literature, so it is important to design a sampling strategy to study DWV variability and to define an adequate sampling protocol. For that purpose, we decided to prepare a list of available primers for the different types of DWV that will be used in the different qPCR assays. And Ann Dalmon and colleagues were in charge of preparing this list of primers. Also, we decided to prepare a catalog of all samples available in each lab to be studied for the presence of DWV, and Anna Gaija and Declan Schroeder and colleagues were in charge of that. Regarding new viruses, there were more than 30 viruses in the literature, and our questions were if symptoms were a unique criteria, what were the seasonal prevalence, as I said, loads of new viruses, they were transmitted and replicating, or were they just passenger viruses? What about wasp viruses and varroa viruses? Are they also honeybee viruses? And how should we relate to all viruses discovered by bioinformatics? For those, we associated the following tasks. First, to prepare a review about worldwide distribution of viruses that was called Diversity and Global Distribution of Viruses of the Western Honeybee Apis mellifera by Alex Beaurepaire, Niels Pio, and other colleagues, and that was published in Insects in this year at volume 11. And the second review that we wrote was about routes of infection and was called Bee Viruses, Routes of Infection of Hymenoptera by Orlando Yanez, Niels Pio, and colleagues, and that was published in Frontiers in Microbiology this year, also volume 11. Finally, we discussed lately focusing in the detection of recombinants by perhaps using a multi-target approach, using different combinations of primers to be able to detect those recombinants and also variants, and probably allowing association of those to their virulence. For that, it is important that we had a database of primers, for example, for the deformed wing virus. We also fed there are many studies that approach virus discovery using immune generation sequencing provide supplemental data. We think that this supplemental data should be presented in a much uniform way, including a dataset of reference sequences for read matching and also information about other viruses present in the bees used in the experiment. In this way, the different studies could be compared and assessed in an easier and methodologically precise way. Finally, we discussed that we need to provide about viruses and their impacts information to beekeepers, perhaps by using a bright light system with red, yellow, and green related to which viruses are present in their samples, what is their load, and what is their prevalence. In this way, we could assess the beekeepers to have a criteria to better manage their apiaries and their colonies. Finally, I would like to wish you a healthy year, and I would like to wish that to see you personally in the next COLOSS meeting. Thank you for your attention from Anne, Orlando, and myself, Nor.
All right. Thanks, Anne and Nor. So if you would please unmute yourselves. We've got a couple questions. I'll give you a second here. So just to connect with one of your last slides about like practicality. So a lot of your work, it seems, is very fundamental, but I mean, what's our prospects of beekeepers being able to like actively use any kind of viral data in their management in terms of like identifying and quantifying those viruses to actually being able to react to that? What's the prospects there?
Would you like to address that, or you want me to answer?
I'll say go for it, Nor.
Okay, so your question was what was the prospect? What is the prospect, right?
Prospects of like, having any kind of practical information about viruses and a beekeeper actually being able to do something about that.
Well, the idea was to trying to create a traffic light system in order to establish what are the most relevant viruses that are identified in the colony, and what is the meaning of having high amounts of such a virus versus such another, in order to facilitate that. That, of course, could create some kind of threshold that over that, it will be very important to see how you manage your colony or how you distance your colony from other colonies in the apiary, etc. For that, it is needed to accumulate data and to see how this comparative data addresses that problem.
Okay, thanks, Nor. Question coming in from Facebook again. Is there a database for primers available? And if so, where, like a public database? Do you want to comment on that?
Is Anne around? So
I think I see Anne is unmuted there. So Anne, if you want to speak up. Okay, Nor, I'm going to say you should answer that question.
Okay. So there is an original list of primers for DWB in the BIBO, and there are publications about those primers. The purpose of ours was to update a database of these primers in order to standardize those.
Okay. Any prospects on like, can you give the audience an update on updating the virus book? Are you involved with that? I know Jay might be working on that too.
We planned and discussed about updating the B-book. This is we are working on it because it is very important since the list of viruses since then has grown, and it's important to give an overall picture of that. Besides the two publications that we have made available to the professional public, actually they can be available for everyone.
Okay. Question from the Zoom chat. We hear about honeybee viruses, wasp viruses, varroa viruses, honeybee viruses and other insects. How do we know who is the original host of a virus?
Oh, this is a difficult question.
And you've got, let's say, a minute to answer that.
Sometimes it's a question of interpretation, but we can consider, I don't know if the question is, if it is important to know what was the origin of the virus rather than the effect of the viral infection on a specific host. For us and for the beekeeper especially, the effect is more important than the origin of the virus. For us as scientists, of course, it will be more basic and interesting to know what is the origin of the virus. So this demands, of course, the study of several hosts and the phylogenetic analysis of the viruses. And eventually, this will lead us to some clue about what was the virus originally from.
Okay.
Some of those viruses are just passengers in the hosts, and some are just, of course, being transmitted by main hosts.
So one final question. Will PCR-based virus detection ever be able to accurately present recombinant viruses?
Ever?
In the short term, let's say.
In the 2020? I think it will be able to represent the main recombinants, I think, based on the data that we are acquiring from other studies and from a new generation sequencing, which is pretty nice. As soon as the more science progresses, we will have more data, and we'll be able to evaluate this tool better. But overall, I think it's a good tool to apply for.
Okay, thanks, Nor. And I see Anne sends her regards there. She's here, but her microphone doesn't seem to work. So, Anne, feel free in the future to write some answers in the chat. But we're basically winding down here. So yeah, thanks, Nor. Thanks, Anne, and also Orlando for that presentation. Jack, if you don't mind rolling through to what I think and hope is the final slide for us. And I'll invite Peter to say a couple closing words if he has anything before turning it over to me again for some final housekeeping things.
Yeah, thanks, Jeff. It's like, well, you know, getting used to an e-conference is a bit tricky. You have all these blank screens, and it's certainly nothing compared to a real physical meeting. But it's all we can do right now, and I guess it will not change soon. So we should get used to that novel form of communicating. And I would like to thank everybody for being actively involved here, asking questions, and I'm very much looking forward to tomorrow. So we will carry on. So, well, everybody, have a good day, have a good night, yeah, and we hopefully hear and see each other tomorrow. Bye.
All right. So yeah, thanks everyone. I just want to thank Allison and Jack from Alabama Extension hiding out in the back. Jack's probably worn a hole through his space bars. He's playing and pausing all these videos. So thanks to both of you. And I also want to thank everyone who created those videos and also hosted those workshops. So some EC members as well as the leaders of various task forces and core projects. Really took your efforts there to make this whole thing work. So from my perspective, all good for today. So I hope you all appreciated that. And I also want to thank everyone on the Facebook live stream for visiting us too. We don't always get the opportunity to connect with our stakeholders as much as we'd like. So we kind of look to take advantage of this virtual situation. So hopefully those on Facebook also really appreciated hearing from us. So as we move into tomorrow, I will say tune in at the same time on the same channel. We'll have that webinar at least for the first portion of our meeting. So please go back tomorrow and click that link, and we'll see you there. We will have this virtual mixer later on in the event, so I guess everyone make sure you've got your hair done and looking good, so we can all turn on our screens and have some little chats with each other later on into the meeting tomorrow. But until then, I'll say hope you have a good evening and see you tomorrow on our webinar link. So take care.